What's up, guys? Good morning, afternoon, evening, wherever you happen to be. It's Wednesday, December 23rd, 2020. I'm Brandon Toy, host of the, we don't currently have a name. Formerly the Ranty with Brandon show, soon to be renamed. Yes, I am on holiday break. However, I had previously scheduled a debate with Mr. Sensible, with Creaky Blinder, what is it called? Creaky Blinder moderating. That's the word. Why do I always forget words, man? Should be pretty fun. We'll see what happens. It's on the Agree to Disagree channel as well. And their thing is, you know, no yelling, no name calling, all that stuff. So Catz and I talked. It should be a pretty straightforward debate. We've got some different topics that we're going to cover. Kind of a formal debate. And we'll see what happens. We're going to talk about Polaris. We're going to talk about Coriolis. We're going to talk about predictions. And then there'll be about 30 minutes for questions. If you do have any questions for Catz, you know what to do. And I will ask those questions. And we'll see what happens. Evidently, he's going to talk about pendulums and some gravity differences. Not really too much into either of those topics, but I think I can handle my own in a discussion. Hopefully it is a good debate and a good discussion, and we walk away having agreed to disagree, I guess is the point. Anyway, let's see who we got in the chat before I give them a call up. Got SE Montreal. What up, SE? Square Law. I thought it was the Branty show. No. I'm staying away from Branty because it sounds like a girl's name. Rebranded. Plain truth. Are you on the rebranded train? You and Ruhif? Maybe. Mind of God, Randy still e-begging like the rest of them. Yeah, I do appreciate tips from viewers who want to support the show. So thank you for the reminder. Let me put that in the chat. And you can do that through Streamlabs, which is pretty easy to use. Super chat, whatever. Certainly don't have to and aren't required to tip for the show, but it is nice. So there's that. I'll pin it at the top. There you go. Question answered, Mind of God. We've got Allie B. We've got John D. Flathead, who was first. What's going on, guys? Allie B says, you got to at least call him a baldy bastard. Maybe I can get that in there at the end, Allie. Hey, even Ruhif can get something right, Travis says. All right, yeah. I thought it was a good idea when I heard it. I just don't know if that's what I want the show to be called. I do like it, though. But I've got to get off my, the pot and make a freaking decision here. That's why I think I'm going to just go with Brandon's, because it's simple and gets the point across. Well, we'll see. I got a couple days before I got to lock anything in. They say never make big decisions until you absolutely have to make them. That's my motto. Put off making a decision until you absolutely are forced to make it. No, just kidding. But that has, I do kind of wait to make big decisions, especially if I don't have to make them right away. Gives you time to think about it. Like becoming a flat earther, that was not a light decision. That was based on empirical evidence and firsthand experience for all of my life. That was a big decision that took months to make. Many of you have gone through the same process. Some of you haven't. That's okay. We can all disagree with each other and have a good conversation. That's what science is about. And that's what we're going to talk about today. Science or something. Toying with the globe. Flat Earth data. Toying with the globe. I do kind of like that. And then Ryan Q. Vincent's in the house. What's up, Ryan? Mind of God. Does the debate even matter now with the vaccine rollout? I don't know, man. If we can wake some people up, if we can, what am I going to do? You know, spend all my time screaming about the vaccine. I've told everyone I know. We've talked about it. I don't know what's going on with that, to be honest with you. It is awfully freaking suspicious. I'm hoping that they are just looking for a cash grab, since they've gotten several $1 trillion out of us in the US at least, and I'm sure that's very similar overseas. Well, we'll see what happens. C flat, Brandon's rantings. Name nods to the history. Brandon's ranting. Not bad. Get the ranty in there a little bit still. SE, I can't believe the sun is out today. Wow, maybe I can catch Jupiter tonight. You know what? I had meant to take the picture of Jupiter and Saturn so that I could participate in Where's Wally's challenge, which is basically just a setup to say, no, you're wrong. But I haven't gotten around to it. So that is still out there from him. You can find that video on his channel if you want to participate in that. So at least we have some FE participants. But I see where that's going right off the bat. I'm fine if they want to say that I'm a chicken, or I didn't want to participate, or Flat Earth doesn't have an answer. I don't care. Who cares what these guys say? I mean, after you've been in this long enough, it's like water off a duck's back, right? Who gives a crap? I don't know these people. I have a different opinion than them, and they want to go around bashing me. I don't care. I don't care. If I cared, I wouldn't be on here. Don't get stuck in his litter box, Brandon. Yeah, exactly, Bill. That's my point, right? I don't want to be stuck in his world. That's one thing these trolls love to do. And I'm just using the word troll a little generously, is get you to go along with their agenda, waste your time, get you to think about the things that they want you to think about, and they will lead you right down to a path of never-ending chasing your own tail. Not really my thing. Anyway, it's 10 o'clock. I got to call in, see how these guys are. Hopefully everything works off. I probably talked for a couple more minutes than I should have, but I got the cam and the mic all set up. So I'm going to enter the broadcast studio and let's get this part going. Okay. Chat and let them know I'm here. I am here. See how this goes. That's their music. Looks like they got live in 30 seconds. Actually, there we go. I am backstage.
Hi, this feels really weird. It's daytime. We don't go live in the daytime. Well, not our daytime anyway. Good afternoon, Mr. Conspiracy Cat. I never thought I'd be saying that on this nighttime channel.
I know. It's crazy, isn't it? I'm never usually up this early. I didn't realise there was even 3 o'clock in the daytime, let alone 2.
Yeah, I know. Generally miss them both, isn't it?
That's it. I like me lions. Yeah. Oh, do it. Well, Merry Christmas, mate. Merry Christmas.
Yeah, and same to you. Same to you. The festiveness is hopefully showing. No, actually, it's not that festive at all. But you know, at least we made an effort.
I think it's beautiful, mate. Those things. I like it. Love it.
Yeah, I can change my background lights.
I didn't know we were going to have to listen to their small talk
if it's required. So, our guest has arrived. Do you want to run anybody through anything first, or shall we just introduce him straight away?
Yeah, let's get him introduced, and then we'll have a quick chat before we start, I suppose.
Okie dokie. There we are. Over to you then, Mr. Catz.
Oh, he is now. It is Mr. Brandon Toy. We were just about to explain to everyone what was going on, so that's timely arrival. Mr. Brandon Toy, or I mean, what do we call your channel now? Do we still call it Ranty? Do we call it Brandon with Ranty? What do we call it?
Well, right now we've been calling it Ranty with Brandon Show, but that's going to change. I am going to rename the channel so people know that it's a different person hosting the show, and Ranty can have his name freed up to do other things. He's got some weird new partner he's doing a show with or something. I don't know. You know, whatever he's off doing. So we'll let him take his name over there, and we'll go with my name. I haven't decided on a name, so if you've got a excellent idea, I'm all ears. I've got lots of ideas. But yeah, Ranty gave me his channel. Can you believe it?
It's that very, very, very generous of him. That very generous of him. But names. What about Gilberto Honsonute? What about that?
Certainly an option that I had been considering, and now that you have mentioned it, it lends more credence to that idea. So yeah, absolutely.
Yeah, well, it's every idea needs considering. So we are here. I mean, we live on your channel now as well, aren't we?
Yeah, we are live on the Ranty channel. So obviously refer to me as my name, Brandon, but the channel name right now is Ranty. Should come up if you just search Ranty, and we're live on there. I've got about 50 people watching so far, so we've got dueling audiences here.
Yeah, I think everybody over here knows is familiar with Ranty, so I'm sure they'll be able to find him. I'm doing a live with Ranty tomorrow as well, actually. Almost Unbelievable special over on the Almost Unbelievable podcast. I'll just shout that out. So we are here because we are going to have a flat Earth debate, but we're going to do a flat Earth debate with a difference. We're going to show people that these debates can happen without screaming, shouting, personal insults, etc. So I'm looking forward to it. We have agreed upon some rules. Brandon, do you want to tell your side what rules we've agreed on?
Yeah, I believe we're going to start off with an 8-minute opening and then go into 3-minute sections. We've kind of chosen 3 topics, which is the Polaris, Coriolis, and scientific predictions.
Mm-hmm.
And questions at the end, about half an hour for questions. We are going to keep it civil and no name calling. Try not to, be dickheads to each other, that kind of thing, essentially.
Absolutely.
Which I don't think we'll have a problem doing.
Yeah. I mean, if anyone's seen this channel, I mean, Creaky, that was why we started this, wasn't it? So we could have debates without any of that. So you'll not get any of that. You will be facing somebody on top of the game, and I will be extremely competitive, but I will absolutely be civil, and I'm sure you'll be the same. So, Creaky, you're in charge of the mute button, aren't you, for when it comes to...
Yeah, so I've got the mute button, and I will mute Catz just as quickly as I will mute you, Brandon, so I will not show any favoritism. Catz tells me that you have quite a substantial slide presentation that you may or may not want to use during the debate. So when you share your screen, it'll pop up on the control screen here, and I put it on the screen then, so... if anything untoward happens with your slides or if there's anything inappropriate, I will pull them down, right?
Okay, sounds good. Fair enough.
So,
let me delete a couple slides real quick. Hold on. No, go ahead.
I'll say very little, unless I need to jump in. The debate is between you and Catz. So whenever you guys are ready, Catz, if you want to, I don't know if, are we going to toss a coin for whoever goes first, or...
I'll let Brandon choose. Who would you rather go first?
I'd be happy to have you go first.
Okie dokie. Just let me find a way to screen share here first, and then I'll be with you. Screen share. See, this is why Creaky does all the tech. Right. So we said roughly 8 minutes-ish, didn't we? Unless we were waffling on for too long, we didn't say we wouldn't... put a clock on it. 8 minute-ish though. Have you got a what am I showing there, Creaky? Is it text?
Yes.
Saying things to ignore. So okay, if we can start with that, and then I'll roughly take about 8 minutes, and then we'll pass it over.
Okay.
So we have got
the screen for you now.
Thank you. So we did decide on 3 topics for the main debate, but my opening is essentially going to be on my view of flat Earth and why I think flat Earth really just needs to be dismissed and gotten rid of. Why it's a pointless thing to be involved in. And to start with, if we are going to be a flat earther, if you're going to go down the road where you're going to be a flat earther, there are things that you just totally have to ignore. You just totally have to ignore and not even want to address. For example, the fact that flat Earth conspiracy must have been centuries in the making. People keep saying how long this conspiracy has been going on for. It must have been centuries in the making by an elite group of individuals existing at a time with no telephones, no telegrams, no reasonable sorts of communication. And they were able to somehow take over the entire world and control all the governments through all the different elections that have happened over decades and decades and decades without anybody ever figuring it out. But we have to ignore that if we're going to be a flat earther, because that gives us a problem. So if we move on, something else we've got to ignore is that in all the time, nobody's ever come forward and said, I'm part of a conspiracy to hide the shape of the Earth. Nobody's ever done it. You know, highly unlikely, isn't it? But that's okay. We can just ignore that and move forward. Because if we start to think about that, it makes flat Earth look a bit silly. We can also ignore the fact that NASA is actually only one of over 70 space agencies that have launch capabilities. And we can always talk about NASA being government funded, and we can say how, you know, the motives that NASA have, but we're just going to ignore the other 70 odd space agencies that are all run completely independently. You know, we have private people, private space launches now. We'll just ignore all that because it's so easy just to focus on NASA and nothing else. We'll ignore the fact that things actually work. So, for example, people who are predicting weather using data from satellites are predicting the weather correctly. So the ability to predict the weather correctly is there, and they're getting data from satellites showing that they live on a globe. But if they're actually predicting it correctly, they must be being fed this data from somebody who knows the Earth is flat and is somehow predicting the weather on a flat Earth and then feeding all that information to meteorologists to make them think that they're using some kind of globe model. I mean, it's extremely farcical. So we'll just ignore that because, again, it's not something we can explain. So we have to just move on. Oops, let's have a look here. Again, things like gyro compasses, sextants, equatorial mounts, starfinder telescopes, GPS, all these things that the engineers design that they think they are designing using maths that is based on a globe and curvature, etc. Obviously, they're all wrong, and they've been infiltrated somehow by some elite flat Earth team that understand how to use these navigation tools on the actual flat Earth. But they've somehow manipulated all these people to think that these tools work only on a globe, and there's some kind of double maths at play there that is fooling everybody. So we'll ignore things like gyro compasses that actually work and sextants that only work on a globe, because again, that causes problems. And we'll ignore the fact that we have geophysicists, astrophysicists, seismologists, and you know, none of their work contradicts each other, and we'll just pretend they're all wrong, because at the end of the day, we don't have to understand how they do anything that they do to ignore them. Once we start to understand it, we realize that it means the Earth can't be flat, and it makes us look silly. So we're not going to do anything that actually means taking on board any common sense. What we are going to do, if we're going to become a flat earther, is we're going to look at a glass of water, and then we're going to say, oh, isn't that water level? It looks a little bit flat at the top. We'll ignore the fact that actually water conforms to the forces that apply to it. So, for example, you can actually physically suspend a droplet of water using electrostatics, right? We can bend water with a static stream. The sea levels themselves, due to salinity and temperature, aren't actually at the same level, but we're going to ignore all of that and just say, it's okay, water's level. And then when we look at the horizon, we can say, well, because water's level, that can't be a curve. Surely it can't be a curve. It's dust in the atmosphere is what it is, and vapor. That cuts off our viewpoint, because we're going to ignore the fact that water actually does conform to forces. Now, we're also going to ignore this picture in the bottom right here, which is what actually obstructed view looks like because of dust and water vapor in the atmosphere. We don't get a clear defined horizon, but we'll ignore that because that doesn't help us in any way as a flat earther. What we're going to do is we're going to ignore everything I've said so far and just say water's level, therefore that isn't a curve. And when we're in that position and we realize that boats go over that thing that isn't a curve, we have to start making up some completely spectacular shit to explain that away, because we're ignoring everything we've said so far. So, for example, I mean, I've given us two options at this point. We can either say, actually, maybe that is a horizon, and the observation of the horizon do comport with the conclusions we get from celestial poles, astronomical observations, sextant, seismology, geophysics, etc. Or option two, like I said, we can make up some sort of spectacular shit and call it research. So we start making things up like the ether band. I debated somebody who said there's a magic band, and if I take a photograph of half a boat, I'm just going to claim there's a magic band there, and that's the reason that the boat disappears, with zero evidence or explanation. So that's one option. The other option is to claim diffraction, and the people who claim diffraction, and I think we all know who we're talking about, have such a low-level understanding of what diffraction is that it is hilarious. The 15-year-old kids who I teach diffraction to understand diffraction far better than Nathan Oakley, or the people that cite diffraction and the Rayleigh criterion as the reason boats disappear from the bottom up. It's so ridiculous, it's laughable. We could say mirages are the reason boats disappear bottom up. But let's play a little game. If you can just take that message off the screen, could you just say thanks? If we play a little game of, so let's spot the odd one out. We have 5 pictures here. Which one doesn't show a mirage? I'll let you have a look at that and then see if you can resolve that in your head with mirages are the reason boats disappear bottom up. We've had this one. Our eyes are curved. I don't even know where to start with that. So then we move away from the horizon after making up spectacular shit, and we start making up spectacular shit about gas pressure. So we get a definition that gas pressure is what happens when gas particles hit the walls of a container. But that's just a Google definition from gas pressure, but it's got the word container in it, so everything's good. We must have a dome or a container. What we'll definitely not do, though, is use any other definitions from Google. We will not use a definition for atmospheric pressure. We'll never talk about atmospheric pressure. We've got to use the one about gas pressure because that's the one that supports our argument, even though it's not relevant to the topic at hand. We're going to ignore other definitions like, you know, we type into Google, what shape is the Earth? All right, we're just going to use this one definition here. That's the one we're going to cherry pick from Google because it's got the word container in it, and we'll say it over and over again. We're going to take little examples like this and say that gas must expand to fill its container. But what we'll do is completely ignore the fact that we have that pressure gradient, and you can prove yourself that with a bag of crisps, you can take it up to the top of a mountain and it can expand. But we're going to ignore the fact that actually on an atmospheric scale, different pressures do not equilibrate. They just don't. But we'll ignore that, or we'll just say something stupid like, you've got to have pressure, a container in the first place for pressure, so let's talk about that first. Because sound bites are way better if you want to be a flat earther than actually talking about the science. We've got to remember that. And it all boils down to, this is my last point now, and then I'll pass it over to Brandon. I think my 8 minutes are nearly up. But it all boils down to a complete refusal to accept gravity exists. That's what everything boils down to. And if you want to refuse the fact that gravity exists, what we're going to do is we're going to think that the only experiment that ever involved gravity was done once by Cavendish ages ago. It's never been repeated. And he was debunked because he didn't use shielding from the wind or electromagnetic waves. And what we're also going to pretend is that the Cavendish experiment only works, or its only point was to show that 2 balls will move to 2 other bigger balls, and that was it. There's no maths involved or calculation of a constant or, you know, reproducibility needed. We just ignore all that. Some guy did it in a shed and he didn't put a windbreak up, so it's ruined. And I have got a lot more to say, but I think that is my 8 minutes, so I'm not going to go up any further. And that's my opening. I will go on mute.
Oh, no sound, Creaky.
Can't hear you, Creaky, mate.
Damn! It's over to you, Brandon. You need to unmute yourself, is what I said while I had forgotten to unmute myself. Apologies. Over to you, pal.
Okay, I believe I'm unmuted. You guys can hear me now?
Yes.
Excellent. Okay, well, thanks for passing it off to me, Conspiracy Catz. That was quite the gish gallop of straw men. I think you've taken every single globe cliche possible and jammed it into 8 minutes, which was quite impressive. It's interesting that you didn't put forward any substantial arguments based on evidence or empirical data, and instead chose to undermine any potential arguments that I might have come up with a bunch of straw men. But I would like to say, just to start off with, that calling yourself a flat earther, being a flat earther, is not an easy thing. If you're not good with ambiguity or uncertainty, then I would suggest that you just stick to the globe model. Because you're not going to easily find answers in Google. And regardless of all the authorities that tell you that you live on a globe, you're going to find evidence that that is incorrect. And the biggest place you'll find evidence is firsthand throughout your whole life. So regardless of what I can find in a textbook, and I can hear from geologists, geophysicists, astronomers, my entire life I've experienced the Earth as if it is flat, level, and motionless. So that's number one. So that's 40 plus years of empirical data that I've collected that say I'm on a non-rotating, stationary, flat plane. So that's my starting point. I've chosen to dig into certain avenues of the globe and try to find out for myself if it's true, if we're on a globe or if we're on a flat plane. And the first one that I looked at, which is the most obvious, is airplanes. I'm going to share my screen here. If you have ever spoken to a pilot and questioned them in depth, you will find very interestingly. Oh, I have to open the system.
Yeah, Brandon,
preference.
you've not shared your screen yet, pal.
Yeah. 1 second here.
Okay, cool.
All right, I'll just share my entire screen here. Sorry about that.
That's okay.
Okay. Let's see if you guys see this or not. You should see yourself right now. And then
No, it doesn't work. Like, you've got to use StreamYard to share, mate. Otherwise, it won't get onto the stream.
Oh, okay.
In StreamYard, there's a button at the bottom that says share screen. You have to use that, pal.
Yeah, I did do that. And then I went through the steps here to share. I think it might be a permission issue. Chrome has lost permission to capture your entire screen. So sorry about that. I'm going to kill my.
That's okay. No rush. Take your time.
Let me just open up the system preferences and see if I can very quickly get this.
Well, I mean, you could always email us the PowerPoint if you wanted, and if you called out the screen number of the slide number, I could share it from my end if you wanted.
Yeah, it's a gigantic presentation. There's 2 presentations,
and
I'm going to flip through the presentation. So just give me a minute. I didn't realize that this would be an issue here. Let me try one more time, and then I guess I'll just have to go with damn it. Hold on.
Are you able to screen share from to your own channel?
Yes, I am.
Because, I mean, as far as I'm concerned, I can see what you're screen sharing on your watch page, because I've got your watch page on one of these tabs, so I can always switch to that if needs be. I mean, it'd be great if we could show it our side as well, but you know, I'll still get a chance to see what you're saying and talking about.
Okay. All right. So let me continue then. So if you've ever talked to a pilot, and I'm talking about pilots that are in this arena, like Bob the Science Guy or Blue Marble Science, what they will tell you is that there is essentially no difference between flying over a rotating spherical Earth and flying over a flat stationary plane. There is nothing from the time that they take off the ground to the time that they land, no matter where they're going to or from, that will tell the pilot that they are flying over a rotating sphere. In fact, the words, "it's as if you are flying over a stationary plane," have been used and have come through their mouth, or they have acknowledged that that is the case. So what I've done is I've analyzed a certain flight, and I want to point out the problem that this brings up. Is if you go from Anchorage, Alaska to here, let me switch here. If you go from Anchorage, Alaska to Mexico City, Mexico, there is a substantial increase in the ground speed of the Earth. We'll just call it ground speed, okay? The rotational speed. So you're going from about, I think it's 80 degrees, 60 degrees north to around 20 degrees north. So if you look at this chart here, 60 degrees north, the rotational speed of the Earth in kilometers an hour is 825. And at 20 degrees, it is 1575. So that's a substantial difference. That's at least 600 kilometers an hour. Meaning that when you take off from the ground in Anchorage, Alaska, you are, we'll just say that you are given that momentum, angular momentum from the place that you take off, which is 825 kilometers per hour. And you have to gain that angular momentum throughout the trip to get up to 1575 to match the angular momentum of the ground in Mexico City. Now, the way that the globe model says that this happens is you are gifted that momentum from the atmosphere, which moves in perfect lockstep with the Earth along the way and are carried through by transfer of energy from the essentially wind to the airplane to gain that 600 plus kilometers an hour as you fly through the air. There is no special adjustments required by pilots other than following a ground track. There's no throttling. They may turn, but it gets lost in any other changes that they would do for the wind. So this seems to me as if it's magic, that you are magically gaining momentum and breaking the law of physics as you fly south from Anchorage to Mexico City. There is no evidence, empirical evidence that can be pointed to say that this is happening. There are no observations other than just implying or assuming that you are on a ball to say that this is taking place. This is wholly theoretical, which is what we find time and time again as we look into the details of the ball Earth model. Now, you brought up that there's this huge conspiracy. It would have to be hundreds of years in the making. And I would say, yes, there has been hundreds of years of work centered around or started by some occultists back in the, say, 1600s, who thought that since the sphere was the perfect shape, that is the shape that God would make the Earth. When you look up in the sky, you do see the moon and the sun, which look spherical. So I guess it is a natural assumption that you too are standing on a sphere in one sense of the word. But they carried that through and time again, essentially confirmed their bias through the years. So I don't think that anything that you can find specific, that you can produce any evidence during this debate that's empirical, logical, that will falsify a flat Earth. All of the things that you said, all of the straw men, and I can address any one of them that you want, even though a lot of these aren't my arguments, seem to be arguments from incredulity, or you just haven't looked deeply into these particular subjects to know that there are plausible explanations for each of them that haven't been addressed by globe model believers. So is it a tough pill to swallow that the Earth is indeed flat and stationary and not a circling globe? I don't think so. I mean, think about what we're being told since the time we are able to speak, if not before, that we live on a giant rotating sphere that is floating through a vast ocean, endless ocean of nothingness, careening around a giant fireball at 66,000 plus miles per hour and traveling through the universe and God knows what else at much more that speed, and yet we can feel none of it. And it's just as if we're standing on a flat and stationary Earth. That's a tough pill to swallow. And I will admit that I do have an argument from incredulity to that, but I go back to all of my life's experience since the time I was born is of living on a flat and stationary plane. So in order for me to abandon that firsthand experience, you've got to provide something that falsifies this fact that I've known since I was a little kid, that the Earth beneath me doesn't move, and I don't feel any rotation, and the Earth is flat. Level is horizontal, level is flat, whatever. I'll yield any remaining time I have.
Okay, thank you, Brandon. Catz, do you want to go straight into the back and forth, or have you got anything to add before you do?
Well, I mean, the agreement was then we just go into 3-minute alternate segments. So I'll kind of use my first 3 minutes as a bit of a response to some of the stuff Brandon said. Then you do whatever you want with yours, and we'll just, if you just mute one of us while the other one speaks, and we'll see where it goes, mate.
No problem at all. There we are. Whenever you're ready, Catz. You went first, so you can go first in this segment.
Okie dokie. So Brandon said, I mean, I think he's right. You know, he did admit that he's arguing from incredulity. And I think if he was more aware of circular motion and how you calculate what acceleration we should actually feel on the surface of the Earth, you know, I think he'd perhaps realize that what we see and what we feel is exactly what we'd expect to see and feel. But let's have a look at the maths surrounding his confusion around Coriolis. So if we really have a look, you know, here's the, I'm on screen sharing. There we go. Yeah.
Yeah, it's on screen.
So Coriolis effect, there's a fantastic website called the Omni Calculator, and you can calculate all sorts of things on it, including the acceleration due to Coriolis and the Coriolis force for an object of a certain size, moving at a certain latitude, etc., and in whatever hemisphere. And I've Googled the numbers here for a typical Boeing 747. Now, I've rounded some of the numbers. You can find them yourselves. You can use the calculator. You know I'm not being dishonest with these numbers. And we can look down at the bottom here at the Coriolis force and the acceleration. And I want you to have a look at those numbers. I want you to have a look at how big those numbers are. Just burn those into your memory for a second. Because the Omni calculator will also do the same thing for force due to drag. For example, for a plane moving through the wind. And when we have a look at that, look at this drag force here compared to the force that we will be expecting to perceive ourselves to feel due to Coriolis. Just look at the magnitude of difference that we have. And effectively, you know, Brandon might be saying, well, why don't pilots make conscious choices to combat Coriolis as they're flying? Well, it's a very well-known fact that planes, whether it be the pilot or whether it be machines in the autopilot, are making very constant minor adjustments against the friction of against turbulence to maintain altitude and maintain the direction they're flying at. And obviously, those adjustments are going to be far more significant for turbulence than they are for anything to do with Coriolis. We don't simply feel, or we have to turn now because of Coriolis. That would be ridiculous. That would just be not understanding how the forces work whatsoever. This is the reason we don't feel that, because any kind of perceived acceleration due to Coriolis is so tiny compared to the constant minute changes we're making due to turbulence, we just don't feel it. However, if you want to talk about empirical evidence, this is the Paris gun. Now, the Paris gun was used in... How long have I got left, Creaky? I can't hear, about a minute. The Paris gun was used in World War I. And it was the first gun that shot so far, I believe it was like 75 miles, that the Nazis had to actually make alterations for Coriolis. And if you look at this book here, Modern Mechanics and Inventions, which was written way back then, you can find a whole chapter in this book about the Paris gun. You can see the maths that they used to account for Coriolis so they could hit the target. You can read interviews with the people who operated it. We can look at people now on YouTube giving instructional videos and demonstration videos on Coriolis with long-range shots. We can find websites and acceleration, scientific papers telling how to measure Coriolis with a smartphone. We can find websites telling us how to correct for Coriolis ourselves when we're going out in the field. It's not a myth. You know, to say that it's a myth is ridiculous. Just go out there and have a look at what is actually going on. And, you know, Coriolis isn't a myth, it's there. I think that's my 3 minutes. I couldn't hear you before, Creaky. I don't want to go out over time.
Oh my God, I forgot to unmute my mic again. I was screaming at you. 3 minutes, 3 minutes.
All right.
Brandon, it's over to you, and I may not mute my mic this time, so.
Okay, thank you. So, interestingly enough, the ballistics tables that you found out, I have researched that, and they do lack empirical evidence. Now, what they do is they assume the equation of motion. So they already assume the ball model. They then fire rounds, see where they land, and kind of back engineer the calculation for force that they attribute to Coriolis. But there are all these other forces that are involved. So there is never an independent variable called Earth spin or Coriolis that is isolated in any of these activities. You've got the velocity, you've got the wind, you've got the humidity, you've got air pressure, you've got gravity, you've got the shape of the ballistic, the temperature of the ballistic, and a whole bunch of other things to contend with. So where in any of this is the deviation due to any rotation of the Earth isolated? The Paris gun is what I would call a anecdotal evidence. So you've said I can go outside and I can see this, and I can listen to people on the internet say that, oh yes, the spin of the Earth is causing this, but you haven't provided me any experimental evidence to substantiate that. You've shown me a calculator that calculates the supposed Coriolis effect on airplanes, but that falls well short of providing empirical evidence, since it is based on the ball model and presupposes the model in the calculations. Again, the pilots make no substantial corrections while they are flying that they can attribute to Coriolis. They say again and again, it is as if we are flying over a stationary plane. So I think I'm going to take the firsthand experience of pilots who actually fly over the Earth, as opposed to a calculator on the internet or an anecdote about a gun used by the Nazis during World War II. I don't think that can outweigh the firsthand experience of pilots. So again, how do you gain the 600 kilometers of momentum as you fly north to south? Where does that come from? Is there a one-to-one exchange because of the friction of the air against the airplane that carries the plane along? And you may call it a minor, very minor correction that could be made over time, which is a trick we see again and again to minimize this effect. This is one of those things that you guys hand wave away and say, no, it's very small, it's very minor, we don't even need to worry about it. It gets lost in the shuffle. Pilots don't need to pay attention to it. It just kind of takes care of itself as you're flying through the air. Again, an example of when we dig into something, we don't find anything substantial.
Okay, well, because I went a little bit over before with you being muted, I'll let Brandon finish his point with that.
Oh yeah, that's fine.
I got my last word out. Substantial. That's good. I'm good.
You sure?
Yeah,
sure.
Yeah. Thank you, though.
Sorry. Okay, no problem. Right. I mean, at the end of the day, I think we've all seen what we've expected to see, and that's nothing but incredulity. I think Brandon has said again, pilots don't make conscious adjustments, even though nobody's claiming a pilot should make a conscious adjustment, because it's such a straw man argument and a straw man model. It's ridiculous. Nobody's claiming. It's like saying you can't pour water on a ball and have it stick to a ball. Nobody's claiming that water should be poured on a ball and stuck to a ball. So to say they don't make conscious decisions, therefore Coriolis doesn't exist, is it's just nothing but a straw man argument. But in what you said there has been absolutely zero evidence that Coriolis doesn't exist. There's been zero effort to debunk the maths around those corrections, and zero effort to debunk the maths around, for example, the Paris gun and other ballistics. What you've essentially just said is, you think the maths probably is wrong. That's essentially what you said. All right, with showing zero understanding of what that maths is. If you could have pulled up the maths and said, this is how it's calculated, this is where they're making their assumptions, if you could have been specific, that would be a different argument. But this is something we fall into with flat earthers all the time. Flat earthers will say, oh, they're just assuming they're just assuming this. The maths it doesn't really work. But they will never actually bring up the maths and explain it. It's like the second law of thermodynamics argument. You'll never hear a flat earther talk about the Boltzmann distribution, how the maths equations work for that, or you'll just never see it. All you'll hear is, oh, it's just the maths and it's been manipulated. But nobody will ever tell me why the maths has been manipulated. So essentially within that, I have heard absolutely no reason why to doubt the fact that the Paris gun had to account for Coriolis. I've heard no reason why, for example, if I share my screen now, something like Foucault's pendulum we've got here doesn't demonstrate rotation of the Earth, other than people saying lies and cheats, If we're going to talk about the rotation of the Earth, these are all the countries here that have a Foucault's pendulum. You can go to any one of them, and we can use the maths that are designed around a globe model to match the latitude with how much drift that pendulum is going to show. You could check it out for yourself. You can actually go and see if it's real, or you could come and tell us how the maths doesn't actually work. But all that we're ever going to hear from a flat earther, unfortunately, is because they just don't understand what the maths behind the Coriolis is. All we're ever going to hear is, it's just maths. And unfortunately, Brandon, I think that's just what I've heard there. I haven't heard anything at all, really, to make me think Coriolis isn't real. It's just your own personal incredulity. If you could provide some evidence that Coriolis doesn't exist, if you could provide some evidence that Foucault's pendulum doesn't work, if you could provide some evidence that a fiber optic gyro...
Did you want to finish?
No, I think if we're strict to the 3 minutes, then that's it would be fair for everybody.
Okay.
Thanks, though.
What you have essentially just said is that it is my responsibility to prove a negative. I am here telling you that I cannot find evidence of the effect that you are claiming exists. That all the firsthand experience and all of the, when you dig into it, the math, which is on the screen right now for how they calculate this for ballistics. I know you can't see it.
I'll screen share it.
Which is what I specifically dug into. And all this information here came from McToon's website, so I'm not ignoring the math. I'm not ignoring the evidence that's been provided. And it comes from a Army manual about the production of firing tables for cannon artillery. Now, albeit it is a bit dated, when you dig into this, you find that they never isolate a variable relating to Coriolis, or the rotation of the Earth. The equation of motion includes an assumption about a value that they assign to the acceleration due to the rotation of the Earth. They fire from point A to point B, plug it into their calculations, and adjust the ballistic coefficient so that their calculations make sense, and they know that they can hit a target pretty close, in close proximity, downrange. Now, how much of that movement along the target path, or a deviation from the target, is attributed to each of these variables? Well, they don't really know. There's not anything on the round itself that senses, this is moving this way because of the pressure. This is moving this way because of the wind. It is all assumed. So unless you can provide some actual empirical data that isolates a variable related to Coriolis, then I'm going to have to say I don't see any evidence, and I'm not willing to assume based on the evidence that's been provided. As far as Foucault's pendulum goes, there are other variables that the motion of that pendulum is correlated to. But first of all, that is a notoriously difficult, I wouldn't even call it experiment, demonstration to replicate. You can read many accounts of people trying to repeat and replicate the Foucault pendulum. In fact, there was one in Canada where a guy used to come out during the day and push the rope with a stick. To me, this is not science. And at the end of the day, you can correlate that motion to the ball model, but you can't identify any rotation or shape of the Earth as the cause of that motion of that pendulum. You brought up another cause. I'm not saying I know the cause. I'm not suggesting a cause, but there are other plausible, all other plausible explanations for the motion of those pendulums. You're going to have to give me something more than a demonstration of a weight hanging and going back and forth on the end of a rope. If that's where you have to go to prove that the Earth moves, I would say you've got a big task ahead of you, because it's not very impressive.
3 minutes.
Okay, so I'm going to screen share again. You said during that you have looked into the maths, and that you know that they do not isolate the variable, or there's no variable been isolated. You know, you've looked into this, you understand. You've just assured me that you are not just looking at this and saying, oh, that's nothing to do with Coriolis, right? You've just assured me that. So I'm going to give you a minute and a half of the time I've got left, and I would like you to explain to everybody what that equation is on the screen, what those things mean, so you can show us that you do actually understand this, and that's not just a soundbite, right? You're not just pretending to understand this and claim that Coriolis hasn't, the rotation of the Earth isn't taken into account. So I'm going to pass it back to you. You get a minute and a half of whatever time I've got left. Can you please explain? Okay, so I'll have 30 seconds left. Can you come back on and use my time to explain exactly what this equation says, please?
No, I don't think so. I'm not going to take a math quiz during a debate. Do you really think that that is a reasonable thing to suggest, that somebody take a math quiz during the middle of a debate to prove that they understand something? So why don't you go ahead and explain it?
Guys, let me just jump in. Catz isn't, I've paused the timer. Catz isn't expecting you to take a maths quiz. He's just asking you to show that you understand the main point of your argument, which I don't think is unreasonable. But Catz, back to you.
Okay, sure. Yeah, I mean, here, let me do it then.
Okay, go on.
That's fine then. Okay, so what you've got at the top is the equation of motion for x, y, and z distances along the respective axes. You've got these variables down below: p for air density, v for velocity, kd for drag coefficient, c for the ballistic coefficient, which I mentioned before, range wind, crosswind, acceleration due to gravity, and then you've got these other values for the acceleration due to the rotation of the Earth. You plug these in here and you solve and you adjust c. So what they're doing at the end of the day is they're saying, okay, we plugged all these values that we know in, all these values which they're measuring with balloons and whatnot, and then they're adjusting c to match their expected outcome, which is on another slide here.
Right. Okay. I'll take whatever time I've got left about that. It doesn't seem to me like you understand that, Brandon. I'll be honest. It seems to me as if you just read out what each of those letters mean, and you are claiming it clearly says in those equations there the acceleration due to the rotation of the Earth is taken into account with that. You know, there's no backward engineering of it. This is used as a predictive thing. You know, we predict what we must change our aim to so we can hit the target, and then it works. They're not shooting and then backward engineering anything. And I think that's the point I've been trying to make, that whenever it comes to things like this, flat earthers don't understand it at all. And they just claim that, you know, it isn't included in the maths. And I think I've made that point quite strongly there, quite heavily, that you don't understand Coriolis, you don't understand the mass behind the forces involved.
My turn?
Uh-huh.
Yeah. Okay. So you've turned this into a math quiz, and if I don't dance to your tune and say the right words, it doesn't matter what words I said during that. You would have said, I don't think you understand it, and fall back on your position. It's a very weak debating tactic. But I will tell you that this slide right here, which I've got on screen, says that this is an iterative process to determine the ballistic coefficient. First, they set c equal to the weight diameter squared, and then they compute a trajectory to ground. The equation of motion are solved for each point using the available data that they have, which means they're just plugging in a pre-computed value for the rotation of the Earth. That computed range is then compared to what they actually observe, and if the range doesn't match, their ballistic coefficient is adjusted by plus or minus c divided by 16, and another trajectory is computed. If the new range doesn't match, they adjust again. The process is repeated, always using the last two computed c's until the computed range matches the observed range. So they are adjusting their equation to match reality. Do you understand now?
Is that, I don't want to take your time. Are you?
Brandon, you've still got a minute and a half left, mate.
Okay. At the end of the day, they are not isolating a value for Coriolis. They are not observing a value for Coriolis. They are not measuring a value for Coriolis. All they are doing is assuming it. based on these other factors, which they can measure, and pre-computed values for the rotation of the Earth. And at the end of the day, adjusting this coefficient for ballistics so their calculations for where the round will land match what they actually see. If it was that if it had the predictive quality of telling them where the round would land, none of that would be necessary. They take the calculations, write it down on the paper, give it to the guys who are going to do the firing and say, follow this, it'll land exactly where you think, according to these values. None of this adjusting would be necessary. I yield.
Yeah, no. Essentially, just no. It sounds to me like you're saying somebody shoots and misses, and then they, I don't know, for some reason go to a piece of paper and change some numbers and then shoot and miss again. I have no idea what you're talking, and you've contradicted yourself enormously in what you said before, what you've just read from the screen. You haven't said anything that makes me believe that you've looked into this maths and you understand the maths. The fact that what you've shown me, if I can get that back up on screen, actually is an equation that has within it the rotation of the Earth in it. I don't know. I'm just lost. I don't know what else to say. That you clearly do not understand it. You've said that you don't think Coriolis is real because you would imagine that a pilot has to make a harsh turn to account for it, which just isn't true. You know, that's personal incredulity. You've said that Coriolis, when we look at corrections for things like the Paris Gono for snipers, can't work because the maths says it doesn't work. But then when I've asked you about the maths, you just read the equation. You've given me no explanation of what this actually is, how it is. You know, you said you looked into it, which means you should have some prior knowledge of it, but you've demonstrated no prior knowledge. So you haven't looked into it. You don't understand it. And I think whatever we talk about with Coriolis, that's just going to be the case. You are just going to say, I've looked into it and I don't see that they've isolated a variable. And that's going to be your argument without ever actually going and explaining it any deeper. You're not going to go into the maths about it. You're not going to explain which variables have and haven't been isolated. You're not going to explain anything other than use that soundbite. They haven't isolated a variable. So that's my take on, Coriolis. I've shown you historical events, historical books, showing how Coriolis first had to be taken into account by the Germans in World War I, nearly 100 years ago, or even not over 100 years ago. I have shown you those historical documents, and you've just said, no, because that's essentially what your answer's been. And then you've struggled to label with the maths. And that's fair enough. Okay, that's fair enough, because we did have 3 topics. We had Coriolis, we had Polaris, and we had predictive models. So if you want to maybe have the last word on Coriolis, we can look onto Polaris. But as far as Coriolis is concerned, I don't think you've actually said anything or brought anything at all other than personal incredulity, I think. But I'll pass it back to you.
Okay, let's see here. So I brought you the actual Army manual and explained to you precisely, showing you the equations and the different variables that are used to calculate the value for Coriolis and the ranges for munitions. You've asked me to explain the equation. You keep insisting that I haven't explained it to your satisfaction, but you haven't explained it either. You haven't offered any alternative explanation. Then you just put words in my mouth and said that I said that a pilot would have to take a harsh turn. Never used those words. Never said a pilot would need to take a harsh turn. You said that I said the math doesn't work out. I never said the math doesn't work out. I showed you how they adjusted the ballistic coefficient based on the actual value that they see in the real world. You gave me an anecdote about the Nazis and their huge long gun. I don't know why you'd have to go back to the 1940s in order to give me an example of where Coriolis made a real world impact. And you also said one of my favorite phrases, which was, you don't understand, which is the motto of ball earthers everywhere. You don't understand. The real matter is I do understand. That's why I've got a 20-point PowerPoint or a 20-page PowerPoint describing exactly what they do. If I didn't look into it, I wouldn't have the information. I wouldn't be able to show you the calculations. I wouldn't be able to describe to you how they change the ballistic coefficient. So you have offered nothing but anecdote, and you don't understand during this engagement.
Sorry. Fair enough. Now, listen, I didn't bring that equation that you've brought because, that was your evidence, not mine. However, I'm going to ask you a question, something I've just noted in the chat, because you have said that you do understand it and you've looked into it. And this isn't an argument for me because I've not looked into it. But somebody in the chat is pointing out, and this is the Rumpus pointing this out, that he is familiar with that equation. And what you're actually talking about is the drag coefficient of the shell. Now, that's something due to, he's saying that's what's not Coriolis force. So I don't understand how you can bring an equation and say it's evidence and you've looked into the maths, then not know what the equation is and have to read it from the page, and then get drag coefficient confused with Coriolis. Can you please clear up the difference between Coriolis and drag coefficient? I'll give you a minute of my time to do that, but just to show that you haven't been confused and you haven't been wrong, can you just do that, please? I'll give you a minute of my time.
Sure thing. So drag coefficient is a completely separate thing in this calculation, a completely separate variable. It's KD. I mentioned that the first time we looked at it. I also had that in the chart here. So you've got a drag coefficient that they're using. The drag coefficient is just one piece of this equation. Makes me question what Rumpus is talking about. And I would suggest that you don't rely on Rumpus for your arguments because he is very often incorrect. So the ballistic coefficient, as you'll see on the screen, is a completely separate variable. That's what I was describing. That's what I read, what that was about. But he couldn't see what was on screen in real time. So he's probably just confused himself, and now he's confusing you.
So would you like to explain what the ballistic coefficient is? Just so because you said that's what they just so I can get my head around your argument that you understand. Can you just
do you want me to describe it again? Because I just read what the ballistic coefficient was. That is what I read again. That is, let's see. Okay. So the raw data, including Metro, are now processed. All parameters except the ballistic coefficient are now available for solving the equations of motion. The ballistic coefficient is this C value, and this is what they adjust in order to make the actual computed paths of the round match the real world path.
So I don't know how much time I've got left. I'll pass over to you in a second. Rumpus just has typed again, and obviously I've not seen that equation before. Rumpus has, and he says that whole procedure you've just outlined, the entire math start to finish, isn't about calculating Coriolis. It is about determining the coefficient of that shell. That's what it's. Now I don't know because I've not looked at the two, but after this debate, when I do look into it, yes or no, am I going to find out that equation is actually to do with calculating the coefficient of the shell, or am I going to find out that you were right and it's to do with calculating Coriolis? Which one am I going to find out is right?
I don't think that I said it was about calculating Coriolis. I said Coriolis is part of the equation. So when you go and look at the equation, which I suggest you do, and stop listening to Rumpus and form your own opinion, you're going to find that they have assigned a value as a part of that equation for acceleration due to the rotation of the Earth. That's just a part of the equation. It's one of the variables that is in the equation itself. So the entire equation's purpose is not to calculate Coriolis. It is, at the end of the day, they're going to adjust the ballistic coefficient and make their calculation match the real world data that they're getting by shooting the actual round.
Can I just jump in? So what was the point of using that for your argument then, Brandon? Because if it's not anything to do with Coriolis effect, it seems a poor thing to bring to an argument about the Coriolis effect.
No, it certainly is about the Coriolis effect in the, here's why. This is what they use. This is the method that they use to determine the ballistic trajectories. This is what the firing tables are based on. That includes this value for Coriolis. You can't use the ballistic firing tables to prove Coriolis because it is just one of the variables that they include in the equation, and it's pre-assumed. It is not empirically gathered. It's not measured. It's just calculated. That's it. It's not evidence of Coriolis. This is a fallback argument of the globe that these firing tables prove that Coriolis is a thing. It does not.
Well, I mean, we'll maybe head on to round two and talk about Polaris, but I will have a look into that equation after this. And I really do hope that you've got that maths right and that you did understand that equation right. I've got a very strong feeling that you haven't and that you don't. But I may be wrong. So I went first on that. Should we jump onto Polaris?
Sure.
Which way are we doing this, Catz? Are we... There's no intro for this one. It's just straight into the 3 minutes each, or...
Yeah, I've had my three, so it's Brandon's turn, yeah.
Okay, Brandon, over to you, pal.
Sure thing. The angles to Polaris are often used to falsify a flat plane. It is said that if you draw an orthographic diagram and show the angles, here I'll give you an example, to Polaris, that is impossible for these angles to occur over a flat plane. However, I would contend that that is not what this shows, that you are mixing up an orthographic view for something that is measured visually, and you have to take into account perspective and the angular size change over distance. The angles to Polaris in the ball model assume parallel light rays from the sun. So no matter where you are on Earth, as this supposed debunking of a flat Earth shows, no matter where you are on the ball, if you look parallel with the axis of rotation of the Earth, you're going to see Polaris. That's a contradiction in itself, and it required Polaris to be put at such a distance that perspective and what's it called? We'll just call it perspective for now. Doesn't come into play. That there would be no significant change to the position of Polaris at any position on the Earth when looking along the axis of rotation. What in reality is taking place is perfectly explained by a flat stationary plane when you take perspective and the angular size change into account. Let me just bring up one more chart here. What you'll end up with is something like this. This shows a plane, but this is the basic idea. When you take the angular size change into account and represent that on a 2D orthographic type view such as this, you would end up with this. You would end up with Polaris being directly above you when you are directly under Polaris, and on the horizon or near the horizon when you are by the equator. It actually matches a flat Earth perfectly. Even on the ball model, lower than 15 degrees in the sky is not to be relied upon when using a sextant or using Polaris with navigation, and that is blamed on refraction, when in reality, that is exactly what we would expect to see on a flat plane. We would expect to see the bottom, we would expect to see that 10 degrees per 690 miles, whatever it works out to, that equal distance to not work out once the object nears the horizon. And I can show you how that looks. This is how it looks on a flat Earth. You can see the deviations in red, but they're not significant.
Okay, so something you've taken from that is that that I've taken from that, from what you've said, is that the observations of Polaris, if we take into account angular size change and perspective, then the maths all works out. Now, I'm going to be honest, I have no idea what you mean when you say that, but you have obviously looked into this really well to say that. You obviously thoroughly understand what taking perspective and angular size change into account means. So can I give you the rest of my time if you can specifically address what you mean by taking angular size change and perspective into the maths of Polaris? If you could, because it's your argument, if you can explain it to me, you can have the rest of my time. So I'm going to fire it back to you, and can you tell me what you mean when you say taking angular size and perspective? But can you explain it mathematically? Please don't show me a graph that you're not going to explain mathematically. Can you actually explain it and how we take it into account? Off you go.
Yeah, sure. As a object moves away from you, parallel over the Earth, it appears to decrease in the sky towards the horizon. So I'm not sure what you're looking for mathematically, but for every increment that you go, every 10 degrees, you will see it fall in the sky, and your measurement to the to Polaris will be 10 degrees lower or higher depending on which way you go. This will fail near the horizon. As you can see, this yellow dot here for 10 degrees shows that the sight line of 10 degrees is slightly off of Polaris. So you're going to have some deviation in the lower percentages, which is what we observe on Earth. And then directly under Polaris near the North Pole, you're going to have slight deviations, which I don't know if we observe because I have never seen it. But essentially, we're talking about two different geometries here.
My 3 minutes back. Sorry, Brandon. I know because this is just because we're in my 3 minutes. Can I just pinch them back to ask you a question on that? You are claiming, therefore, I mean, that to me doesn't make any sense. And when I get my next 3 minutes, I'll show you why. But you've not mathematically said how perspective can allow us to maintain the observations of Polaris, which is a what is it, like a 69-mile movement and a 1 degree drop in the sky, while then incorporating the maths of perspective and the angular size change. I wasn't aware Polaris changed its angular size. Have you got any evidence of Polaris changing its angular size? And can you tell me how you incorporate that maths into it? Off you go.
I wasn't referring to the angular size change of Polaris. I was referring to the angular size change of the apparent distance between Polaris and the horizon. Not Polaris.
As long as you can mathematically explain it. If you can mathematically explain it, you can have the rest of my time. If you mathematically, because you said the maths works out, so can you work it out with the maths?
That's okay. I don't need your time. I don't know what you're looking for. Why don't you describe the math of Polaris to me, and why don't you try to falsify my model with math, and then we'll discuss the differences where they lie.
Yeah, no problem. Okay, so I'll explain that. Just I've got to get my PowerPoint back up. I do seem to have temporarily lost it.
I'm going to try my very own experiment while you were doing your next 3 minutes. Can Creaky go and have a pee in the time it takes Catz to present?
I've done it. I'll crack on while you're having a pee, mate. So essentially, if we look at the screen here, we're just talking simple trigonometry, right? Now, I've made these numbers up, right? Now, over on your channel, all the flat earthers will be saying, oh, he's made the numbers up, therefore it's wrong. And instantly, they're not going to get the point. The point is about simple trigonometry. So try and keep that in your mind. I didn't want to use massive astronomical numbers here. So essentially, when we want Polaris to drop 1 degree in the sky, on Earth, we move about 111 kilometers. We move south 111 kilometers, and it will drop 1 degree in the sky. That is the observation. Now, if we apply that to actual trigonometry and mathematics, which we've got here, we will see that if we wanted it to drop 1 degree in the sky by moving 111 kilometers, the actual distance itself of Polaris to Earth has to change. Now, we know Polaris is a set distance from Earth. We can't say that Polaris is a different distance from Earth for every single person observing it on the planet. That would be ridiculous and made up and fairy tale-ish. Polaris is a fixed distance from Earth. So when we look at just basic SOHCAHTOA trigonometry that you get from school, how on earth can we have a 111 kilometer movement which results in Polaris dropping 1 degree in the sky if the Earth is flat? Now, you said we can somehow mix in the maths of perspective to this. So I'd love to see, because you obviously said that, so you understand what you mean. It's your argument. You obviously understand, because you've looked into it, how to put the maths of perspective into this to make it fit our observations. So what I'm asking is, can you do that? Can you give me the maths of how it works and how it, fits in with trigonometry that we know works? I'll pass back to you.
Yeah, I notice you fall back on math instead of logical arguments a lot. You have this habit of asking for an on-the-spot math quiz, but what I'm going to provide you is a concept that very easily falsifies your model of how Polaris works on a globe, which is a finite vanishing point. On Earth, I am sharing something on my screen.
All right, I'll share it.
Objects that are parallel to the surface of the Earth and move away from the observer recede into a finite vanishing point, meaning their apparent size and distance above the horizon diminishes to the point where they literally vanish into a vanishing point. So depending on their height above the Earth, that will determine the angle at which they recede towards this vanishing point. Your diagram here, which is similar to this one based on pure trigonometry, pure Euclidean math applied to visual space, is incorrect because visual space does not adhere to Euclidean physical space. The two are separate, different things. And one of the major differences, according to the modern science of optics, is a finite vanishing point. On this diagram, let's say this man moves, I don't know, he moves away much further than this. Doesn't matter how much further he moves away, the end of this building is never going to recede into, is never going to get lower than this. You're always going to have a Euclidean physical parallel line drawn on this piece of paper with an angle coming from his position to this corner. You could go back 100 or 1,000 feet off of this page and you would still have that. You would never violate this space down here, meaning there would never be a vanishing point. But in reality, there is a finite vanishing point. And what you get if you apply this Euclidean model to the Earth is you get a sphere. You mistakenly get a sphere because you are applying orthographic Euclidean physical properties to a visual observation and measurement of where Polaris looks like it's in the sky. It doesn't have to be in different places. That's like saying that if I look at some street lights going down the street that they're going to be in different places. That doesn't have to be in different places. You're just applying the wrong math to the problem. I yield.
Catz?
Okay, so the answer was no then, essentially. I mean, I showed you trigonometry and how on a flat Earth, we would have to break the laws of trigonometry for Polaris to behave as it does, as we see it. I asked you, could you explain how we take the maths that you cited? You cited the maths of perspective. You said that, just like you said when we were talking about Coriolis, about the maths of Coriolis. And yet again, when you have cited that the maths says one thing, when asked about the maths, you have not been able to explain it. You have, Brandon, you have to stop saying that the maths say one thing if you're gonna then not be able to explain it when asked what the maths prove. Okay, so I mean, I don't know where to go. We're still in the same position where the observations of Polaris break on a flat Earth all the laws of trigonometry. You've shown me this diagram here without giving any sort of explanation where the hell these numbers have come from at the bottom. Like, you know, we've got over here a calculated 26.7 degrees and an observed 0. You made no effort whatsoever to tell me what those numbers mean. I mean, like, you're saying that this proves your point, but you can't tell me why. You won't tell me why. You won't try and put the maths of perspective, right, into the trigonometry that we know actually works in the real world. You've said vanishing point because we do know that a vanishing point is a real thing, but it seems that all you think is saying vanishing point and then showing me a diagram with completely unjustified numbers in any way represents a coherent and logical argument, and it doesn't. You know, let's go back to a coherent and logical argument, which is this one. We can mathematically and in the real world prove that things do not descend angularly on a linear scale. So in other words, on a flat plane. So if I walk back 10 meters and then another 10 meters, something I'm looking at will not drop the same number of degrees in the sky for each of those 10 meters. It is not linear on a flat. That is what trigonometry tells us, and it is what we see in the real world. You told me the maths of perspective would correct this, and then you didn't tell me what the maths of perspective were. You told me that Coriolis wasn't identified as a variable in any equation. Then you showed me an equation before that you didn't understand. And I just think this is something really common with flat earthers. And I noticed that you didn't like me bringing up the maths, and you said I bring up maths too much, but I don't think anybody doubts trigonometry is real and works. And, you know, nobody's going to doubt Sokotoa as being able to predict the angle we should see something in the sky. So please, just one last time, can you tell me what you mean and articulate it when you say the maths of perspective can be combined with this to show us what we see in the real world?
3 minutes.
Yeah, so you keep saying that I haven't shown you any math and that I need to show you math. What I'm showing you is concept, Catz. And you keep asking for math. I noticed that you didn't address my main point, which was that there's a finite vanishing point, and that the measurements to Polaris don't take into account the decreasing distance between the horizon and the apparent position of Polaris. You haven't really addressed my arguments. You've just whined and cried about there not being enough numbers on the page for you. I'm not sure. I mean, all you showed with math was, oh, Polaris descends towards the horizon or appears lower on the horizon for every 690 miles or 1 degree for every 69 degrees. And then you've applied Euclidean physical trigonometry, as you called it, to a visual perspective measurement. When you do that, you're applying math that doesn't apply to the situation at hand. This is pretty easy to understand, and I don't know where you're struggling. But essentially, let me show you the concept.
Brandon, let me just jump in. In fairness, there isn't anything in the real physical world that hasn't got some form of tie to maths for working out a certain element of it. So are you saying then that trigonometry is completely wrong?
I'm not sure why you're jumping in this debate, Creaky. I'm not sure why you're now asking a question that seems to support Katz's position and his question. That is this turned into a 2-on-1?
No, it's not a 2-on-1. I am here just to moderate, and if there's anything I'm not sure or I'm not following, I'm gonna jump in and ask. And if that upsets you, then sorry. But you know, you were saying that the Catz is banging on about maths too much. That's because maths is applicable to everything. So I don't see. So you were saying that trigonometry isn't a thing that applies to anything you're talking about.
Yes, trigonometry does not apply as it's used in Euclidean physical space, such as engineering drawings, when you apply it to visual observations such as these. Now, Catz did make a claim during his last segment, which was that we can prove that this is not how it works on a flat plane. So I'd like you to show me an observation that falsifies that this is how it would work on a flat plane over a distance of, say, let's go 10 miles.
Yeah. So essentially, just so I can clarify what you're saying, and I'll do this, put it in a video for you, no problem. You're saying that if I choose an object and then move 10 miles back, and what you would say, and apply the flat Earth view, you're saying what you want me to prove that trigonometry works, or trigonometry doesn't work? What is it?
No, I want you to prove that your application of trigonometry, the Euclidean physical space trigonometry, is applicable to a perspective visual observation, such as an object descending towards the horizon at distance. So yeah, over distance. And I also want you to still address the finite vanishing point and how that's possible with your model.
When you say a finite vanishing point, it seems to me we can get to that, but it seems to me we started talking about Polaris and the angles of the sky. You then produced a graph with numbers on, and you couldn't explain where the numbers come from. You couldn't explain how the numbers were calculated. And then when I started to press you on to actually tell me how those numbers were calculated, because you said you've looked at the maths and you can incorporate perspective into this. It seems like you don't want to talk about that now. You've brought up the point, the term vanishing point, which we can talk about. But am I to assume that we are done now talking about the height of Polaris? Is that something you don't want to talk about anymore?
This is
Do you
all
want to talk about the vanishing point?
Those concepts are about the height to Polaris.
Okay.
A finite vanishing point falsifies your model of how the angles to Polaris would work on a flat plane.
Can you explain specifically why?
I did.
Yeah, and when you did that, you showed a diagram that had numbers on. Those numbers, you never explained where they come from. We never explained how they've derived. You never explained that you understood anything about the diagram, but yet you're telling me you did explain. So can we go back, and I'll put that diagram back on the screen, but this time, can you explain where the numbers come from?
No, the numbers aren't important. I didn't describe the numbers because they weren't important to the concept.
So it's just a diagram. That's not a problem. It's not a problem.
Yeah.
I think when it comes to Polaris, ultimately the maths backs exactly what we see. It doesn't back what we would see on a flat Earth, but you're going to say vanishing point without any explanation.
Finite vanishing point. So, debunk a finite vanishing point, please.
Just explain again, and I will do, what you mean when you say a finite vanishing point allows us to move 111 kilometers and see Polaris drop 1 degree in the sky.
And don't worry about that part. Just debunk the finite vanishing point, because it debunks your diagram of how Polaris would work on a flat plane.
So we're into the world of straw men then. So basically,
no, it's not straw man. This is the argument that you made based on trigonometry. I'm telling you a finite vanishing point debunks it, and you have no response.
Yeah, the response is it doesn't, and it's just made up. I don't. You've just said the word finite vanishing point. You showed a diagram and said debunk it. Like, debunk what? You've not presented an argument.
I did present an argument. You didn't understand the argument, possibly, but I did present an argument.
If you present it again, we will all listen. I'll screen share now. You can have your. We'll start again. You go on your 3 minutes, and can you explain specifically, in real detail, your vanishing point argument? I will make as many notes as possible, and if I can't respond on it now, I will make an entire video on it. And if you're right and I'm wrong, I will apologize and I'll shut my channel down. So I'll start making some notes now. Please, please, please explain the finite vanishing point again. I'll mute myself. I'll screen share your thing, and you can have the full 3 minutes. Off you go.
Okay, well, this doesn't really take 3 minutes to explain. Let me bring back up your diagram of how it would work on a flat plane, which is basic trigonometry. So you understand basic trigonometry, I'm sure. And we'll just ignore these numbers on this page. Okay, this is just conceptual. Ignore all this. We don't have to get all twisted up in the math. All we need is the concepts. So here I am. Let's say I'm standing 90 degrees under it. I'm looking up. I move away a certain amount. We'll just call it an even amount. These are even spaces, these colors, right? I look up, and this position never changes, right? You hold this position constant because this is a Euclidean physical orthographic diagram, such as how if you were building this, let's say this was some contraption you were building, you would draw it out like this. However, what we're measuring in the real world is how Polaris appears, its distance above the horizon, and where we see it based on how we see, which is perspective based. In perspective based space, there is a finite vanishing point, meaning that at some point, as something parallel to the Earth moves away from us, it is going to appear to descend into the horizon. Everything is going to disappear into the finite vanishing point. You can take a look at these trail tracks, even though there's a hill back here. Everything will go to a finite vanishing point. In your diagram, in your trigonometry-based diagram such as this, there will never be a finite vanishing point. This space between the ground and the parallel path of object will never be violated, meaning this does not match how we actually view the world. It may match the physical space, but you cannot then say that these are sight lines because you're measuring something. You're applying a physical Euclidean measurement to a perspective-based observation. That's it.
Okay, so keep screen sharing. You got your diagram on screen. Just a quick yes or no. These gaps here that I'm hovering over, are they meant to be even distances as we move back from that building? Or are they meant to be different distances?
Let me see what you're looking at. Yeah, those are meant to be even distances, yes.
So these even distances, as we move back an even distance, what we are getting is a different... we are getting a different check. So for every sort of like 10 miles I move back or whatever, I'm getting on a flat plane, I'm getting a different change. I'm getting a different angle to whatever the top of that building is, am I?
That is the supposed debunk of Polaris over a flat plane, or any of these site-based observations at long distance over a flat plane. This is right, this is your model here that we're reviewing. This is your model of how it would work on a flat plane.
So the difference is, what you basically show me here is a series of triangles with somebody who's measured no distances, done no calculation, done nothing. They've just written some angles there. Whereas what I've actually done, and I'll just stop screen sharing, I'll put you here, is put numbers on mine that actually work.
Numbers. Woo.
And that we would actually see. I can tell you how these numbers will be calculated. Listen, I think what we need to do is show why yours doesn't work. So let's do this step by step. The first thing I'd like to ask you, and then we'll apply this to yours, we'll put some distances and stuff to it, is how would you mathematically calculate this height to Polaris here? What equation would you use to calculate this height to Polaris?
In the physical world or site-based?
Just give me some maths. Give me some trigonometry. How would you calculate that height to Polaris there based on the numbers that I've put on this diagram?
Okay, again, we're talking about trigonometry for a site-based observation. So this is
Just,
my whole objection is there is a finite vanishing point in reality that objects will appear on a flat plane to descend into the horizon, whereas on your model that never takes place. That's the whole argument. We don't need to write numbers on the diagram.
I don't mind asking you questions.
We don't need to do any mathematics during the show. You just need
it's a very simple question. It appears to me very strongly
there is a finite
that you don't understand trigonometry. And because you don't understand trigonometry,
that's why I have that diagram in my presentation, and that's why I'm discussing it in great detail.
Rubbish. Brandon, so you've been muted on here, but I'll pass it over to you for your 3 minutes. My last sentence was, because I don't know if you could hear me because you were talking, my last sentence was, it's very clear to me that you don't understand how to actually carry out trigonometry, which is why you don't understand why the diagram you've shown us doesn't work. It's your 3.
Catz's argument, again, you don't understand, ignores the argument that I've made, doesn't address any of the points I made, goes back to numbers and trying to get me to do a math quiz during the show, has no substance to it other than to attack me for my inability to conjure up some numbers that he wants me to conjure up on the concept that he brought to the table, and won't address why there's a finite vanishing point in reality and how he debunks my perspective-based site angle model to Polaris, and doesn't understand the difference between perspective space and Euclidean physical space, won't acknowledge that there's a difference, which is well established within the science of optics and psychology. I yield.
Okay, Brandon, I think my point is very simple. How on earth am I supposed to believe that you have created some kind of perspective-based model if you can't do trigonometry that children in UK schools learn at 14 years old, 13 years old, some of them? How can you come up with the angles that you... Let me share your screen again, my screen again. You have presented this. You have presented and said that it's a perspective-based model, and it all works out right? All the maths works out, but you won't tell me why the maths works out. And the reason you won't tell me is because you don't know. And the reason you don't know is because you've forgotten from when you were at school how to do basic calculations like trigonometry, which is fine to forget. I'm not having a go at you for forgetting how to do trigonometry, but what I am saying is, given the fact that you lack such basic mathematical skills, how am I supposed to accept that this here on the screen is anything to take seriously when you just slap some numbers on and you've no idea where those numbers have come from? So I totally reject your argument against Polaris. It seems to have just been conjured up out of nothing. You know, like, I don't know. I'm not trying to have a go at you for your lack of knowledge of maths, but you have to be honest and say, okay, I don't know how to do trigonometry. I've forgotten. And then the next question will be, well, therefore your maths, your argument is based purely on a concept. So can I ask you just one more time? And then we'll leave Polaris and go on to something else, because I think we've hit a dead end. Can you please tell me how you would arrive at the height to Polaris?
That is not my model that you keep bringing up. That is your model for what debunks Polaris over a flat plane for the third or fourth time. Why are you interrupting my time?
It's still my time. I didn't yield. I asked you a question, Mike. I'll ask you one on your model. This building here, okay, how would you calculate on your model the height of the building? It's your model, so how would you calculate the height of the building?
Here's what you need to do. You need to tell me how a finite vanishing point is possible on in reality.
That's okay. We'll leave it. I'll hand it over. You can't, and I think that's
and
what
why your diagram doesn't represent a finite vanishing point on a flat plane. This is your model. This is your debunk model, and all this going on and on and on about how I don't understand triangles. I mean, that's your argument. You don't understand triangles. You forgot what you learned in school. That's your argument. You're real, dude.
I think what we've proven is essentially you've brought an argument here based on angles and distances, and you've got no understanding of where these angles and distances have come from.
That's ridiculous.
You haven't got the well, but this is it. This is what flat Earth is. Flat Earth is people that don't understand the very basic stuff, thinking that they can come up with fantastically made up arguments like a vanishing point explains the observations of Polaris, or diffraction explains ships vanishing bottom up. They are completely made up points by people that don't understand the very basics. So I'm not having a go at you by saying you don't understand it. I'm just pointing out you do not understand it. Please listen to that. Please, educate yourself a little bit on trigonometry and then reassess the model that you've brought, and you'll realize it doesn't work.
Just a straight ad homs and character assassination, and it's just ridiculous.
It's not an ad hom. How is it an ad hom?
You don't understand. You must have forgotten from school. You don't know how triangles work. You don't know how angles work. You're just a dumb driver. You should listen to me because I understand and you don't understand.
Brandon, that isn't how we behave on this channel. No kiddie voices.
How was I behaving? I didn't cuss.
I which I've now done. I'm going to unmute you now, and Brandon, you get to speak first. Catz, give Brandon a chance.
Okay, thank you.
No problem.
So your argument is essentially that I forgot my math from school. I don't understand triangles or angles, and that I'm just a confused flat earther who doesn't understand and should listen to you. That has been your argument for the last 10 minutes. And I got to be honest, it's a pathetic argument. You won't address any of the points that I've brought up. Why, in your supposed debunk of Polaris, which you keep showing and saying is my argument, when it's just a formulation of your argument, that I don't understand why those angles are on there. I know how triangles work, Catz. I understand how triangles work. I also know that there's a difference between Euclidean physical space and perspective visual space, which you don't seem to understand and won't acknowledge. So I agree. Let's move on. I'll yield the rest of my time, and let's see you bring some actual evidence to the table instead of attacking what I know, saying I forgot everything from school, don't understand triangles, wrote something on a piece of paper and didn't understand it, and flat earthers, they don't understand. How about some actual evidence for a change? I yield.
Okay. Well, you did bring me some evidence. You brought me this evidence here that I'm about to screen share. You told me that you understood perspective and how perspective works, and you just told me specifically you understand triangles. The point I'm making is this explanation you've got to explain away the observations of Polaris is only useful if you understand how to come up with these angles and numbers in the first place. Otherwise, it's nothing. You can't tell me you understand your own argument and you understand triangles if essentially you can't do basic, let's find out the length of a triangle. I mean, I don't know where to go with that. I can't. I'm not trying to be mean, but if I took my car to a mechanic and I said to the mechanic, oh, my car's struggling, there's something wrong with the engine, and he starts rooting around in my glove box and brings out, a spanner and says, oh, look, I've got your engine here, I'm not going to really have any faith in anything else he's got to say. And it's the same here. You've brought me something with numbers on, and that's it. You've no idea where the numbers have come from. You haven't got the mathematical skills. You can't demonstrate the mathematical skills to make me believe you know where those numbers have come from. So I'm just going to throw away anything you've got to say about Polaris because it was just meaningless. And I don't mean that. I don't mean to be nasty. It was just meaningless. So we go on to the next point, and you can have the 3 minutes.
Right, Catz, just for you to be aware, it's 30 minutes until show end. So I don't know if you want to go into questions or if you want to tackle the next point. I don't know if you and Brandon have got a preference or what.
I'm going to be honest. The next things I was going to talk about was pendulums and how they don't rely on density, but they do rely on gravity, and they change on the. I was going to talk about the Ottloss effect, but we're going to need to actually understand a bit of maths for that. And
okay,
I've hammered my head against a brick wall enough for that. So let's go. I'm happy to go to questions from the chat.
Yeah, Brandon, are you happy with that as well, mate?
Sorry, yeah, I'm good. Yeah.
Yeah, cool. Okay. So if anybody does want to ask Brandon or Catz any questions relating to the debate at hand, obviously not, what they had for lunch or anything, then tag at agree to disagree in the side chat and I will pop them up on screen and we will do it that way. And I mean questions. I don't mean insults, whether you disagree with Catz or disagree with Brandon, I mean questions. So fire away, guys, and I will pop them up on the screen.
Can we have an opportunity? I might have a couple questions come this way too.
Yeah, sure. Of course.
Yeah, same thing. As long as we're respectful, yeah.
Right, Brandon, we have got the first questions come in. I wanted to ask this earlier because I haven't got a clue what does Euclidean mean?
Physical geometry, essentially. Euclidean.
Right.
Euclid.
Right. I knew somebody would ask what you had for breakfast, but no.
I didn't eat breakfast. I just had Catz for lunch.
Same here. Right. So the next one is from Krana79. Ask Brandon, if the vanishing point is finite, then where is it?
Where is the vanishing point? It is at the it depends, because in reality we don't always see it on the horizon because of atmospheric turbidity or compression of the horizon, or just we can't see that far in some cases, or we can't see distinct objects at that case, so it looks like it vanishes off into nothingness or into fog, if you want to call it. It's not visible, but it's near the horizon.
Right. Okay. What have we got? Chris S says, I have a triangle with sides 1, 1, and 1. What are the internal angles? And that's for you, Brandon.
60, 60, 60.
I understand why that question's been asked, but I won't bring it up, obviously.
I do too, because I got accused of not understanding triangles for half the debate.
Smash that ballpark.
Yeah, that's why I understood it, but there we are. So, sorry, that was the one I just had up. Where are we? Right, the rumpus. Please explain the maths for perspective geometry. Show how you would calculate the angular size of an object using perspective.
Please
I'm
explain
not sure who that's for. He hasn't specified you, Brandon. He's just tagged agree to disagree. So the rumpus, I don't know if that's for Brandon or Catz. I don't know if you want to clarify.
I can step in that if you want.
Yeah.
Okay, I'm just getting something to.
Sorry, it's for Brandon. He's just replied now.
Yeah, so I don't have the calculations handy, but there are calculations. The problem is at a distance, those calculations are based on the ball model. So if I give you the calculation that you'll recognize, Rumpus, then you'll say, well, that equals a ball. That's why I asked Catz to falsify my model of how perspective works at distance, because what if this all comes down to, the crux of the entire issue is how perspective works at distance. If you calculate it one way, Earth's a ball. If you calculate it another way, the Earth is flat. But there are calculations.
Yeah, can I show one, Creaky? Can I?
Yeah, you can screen share if you want.
Now, listen, before anyone jumps in, I know Rumpus's maths is very, very good. This is how we boil it down at school. You'll hear people like Red's Rhetoric in debates give the arctan formula or whatever. This is just a nice, simple way of thinking about it for anyone who might forget. This is how we do it at school. If we assume that around us, is like a circle of vision and the distance to an object is the radius of that circle, then this little ratio up here is a nice little way to calculate. Now, it is taking a little bit of liberties with the idea that it's a circle. It's not going to be as exact as the other equation, but certainly over long distances that it will going to become a little bit more accurate. And it's just a nice little ratio here of figuring out the absolute size of something at a given distance, or the angular size if you know its absolute size. So I won't go into the other equation. I don't think there's much point. But that's a nice little taster. However, what I will say is that has absolutely nothing to do with Polaris dropping in the sky. Like, the two things are just apples and oranges.
Okay, the next one from Bearded Devil 1864. Have Brandon draw out his claim actually using perspective from the point of view of the observer.
Yeah, Creaky, I'll have to decline. I don't
Okay.
I don't entertain this person who's asked this
Yeah,
question.
no, that's fine. Like I say, you're not obliged to answer anything you don't feel comfortable with. It's absolutely fine. Right, let's find another one. How does Brandon follow? Right, sorry. How does the following phrase relate to trigonometry? The old Arab sat on his camel and howled.
I'm not familiar with that. It must be a what is it? A mimic? I'm not familiar with that one.
It's maybe you've heard of Sokotoa. It's just a different way of saying Sokotoa. It's quite famous. What I think, if they ask Sokotoa, what would your answer be?
I have no idea. I've never heard of that.
What would it be if it was, I don't know, sine, opposite, hypotenuse, for example? What would that be, maybe?
So we're going to go into a trigonometry quiz again?
No,
is that what we're going to do? Is that what your entire argument this afternoon is going to boil down to?
It's a totally irrelevant skill to flat Earth science. I agree.
It's a totally irrelevant skill to understanding concepts that we've presented here today.
Right. So third finger from the right asks, again, sorry, but it's to you, Brandon. Ask you why elevation changes the vanishing point.
It changes your angle to the objects in the distance. So obviously, the higher up you get, the angles to things that are above your head or parallel with the Earth are going to change. So you're going to see a vanishing point in the distance, since the compression of the physical space near the horizon is now opening up, and that angle is less.
Okay, the next question, which thankfully has nothing at all to do with maths, but sadly it is for you again, Brandon, and it's asking, as you would expect, I'm sure. Can we ask you if you have a photo of Polaris taken from Australia? And I think what he's getting at is, why can't you see it from Australia?
It's just flat out too far away. I mean, you can't see forever on a flat Earth, and depending on the height of something, that's going to determine how far from the object you can see it. That and other factors.
Catz, do you want to jump in on that or no?
Well, I mean, there's absolutely nothing to suggest at all that we can't see Polaris because it's too far away, and there's nothing to suggest about how light works and the fact that light enters our, we see something based on whether light enters our eyes. If we're being told somehow that, we see the light from all the other stars, but then somehow when we pass the equator, those stars are too far away because we've traveled an extra 50, 60, 70 miles. It's just ridiculous, isn't it?
Kranos79, I think this is in response to the answer you give to his last question. I'm not sure if you can remember it or not, but isn't the vanishing point finite though?
Who's that to?
That's for you, Brandon.
Yeah, it is. It is finite.
I think it's a follow-up to Krana's first question, which I haven't got now. I'm afraid it's long gone in the chat, but
yeah, I mean, you can change your vanishing point based on your height above the Earth. That doesn't mean it's not finite. You're still going to have a vanishing point that is finite. It's never going to be infinite.
I thought finite was a fixed point, though. It's not, is it?
No,
I'm not.
It's
certain.
just it is a non-infinite distance away, meaning it doesn't go on forever, like a parallel line above the Earth that goes away from you. It's not going to go on forever. It's going to appear to. Well, I'm having trouble with words today. To end at the horizon at some point, which would be the vanishing point.
Okay. And math, it would seem, which brings us nicely into our next question, which is from some guy called Conspiracy Cats. Can you ask Brandon how to calculate the length of the side of a triangle?
Calculate the length of a side of a triangle. Oh, no. I'm not going to play Cat's game anymore. Sorry, tell him I said no.
I will be sure to reply to him immediately. Daryl M says finite is a fixed point, which is what I thought it was, in fairness, but I'm not certain enough to argue the toss. Catz, have you got any thoughts on that? I thought it was, and I could be completely ignorant. I thought infinite meant it never ended, that it couldn't be fixed, and I thought finite meant that it's there and it's always there and can't move, or it wouldn't be considered to be finite. That's how I thought it worked anyway. But I don't know.
Right.
It's just the opposite of infinite.
Yeah. Well, finite is a physically fixed point, isn't it? When you look at, for example, meteor showers, they all come from what look like what's that the name of it now? Like a point of origin that comes out, the final. But it is just perspective, isn't it? That makes it look like that. But you've got to go a hell of a long distance to get that effect from something as like meteor showers. I don't know why I'm talking about meteor showers. What was the question?
No, yes, it wasn't a question. I asked you a question. Daryl M says finite is a fixed point, which is what I thought it was, and I just asked you both to clarify it. So,
well, the way it's used in the optics publications is meaning that it's not infinite. There is a distance to it that is visible, a finite vanishing point.
Right. Okay. Right, it's 15 minutes to go, Catz. I think we need to go to the super chats if everyone's okay with that.
I do have a couple questions, if I could.
Yeah. Oh yeah. Sure, fire away, mate.
Okay, we've got one from the Plain Truth. Ask Catz, is it possible for refraction phenomena to obstruct distant objects, such as ships, islands, lighthouses, etc.? And then there was a second part. Did I ever use the word magic when explaining my claim for the ether band in our debate? So I guess those are two separate questions. The first one was, is it possible for refraction phenomena to obstruct objects, distant objects?
Okay, right. No, I'll just screenshot. I use the term magic because that's what your ether band is, and I'll explain why. So yeah, if we look at refraction here, look at how they're being obscured. Look at how. All right, look, that's not a clear defined horizon. Compare it to a picture like this, and me and Travis did go back and forth about half an hour, and he refused to explain how this is caused by the same phenomenon as that. So that's my answer to that, Brandon. Not Brandon, sorry, Travis. Yeah, that's refraction obstructing something. This is the horizon. Get the two sorted in your head. Thank you.
Okay, then the second part of that question was, you answered that already, the magic. Okay. Let me see if I have any other questions. I don't think so. No, I'm good.
Okay, cool. Right, so we'll go to the super chats, which will be extremely boring for everybody except me because nobody else can see them. Or no, you can see them, Catz, can't you?
Oh no, I'm not logged into the. I'm logged in.
Yeah. Shut. Get lost, Google. I know I don't understand either. Harley. Oh, shut the hell up. Pull your plug out. Oh my. I did not want to turn my lights off. Okay, Google, turn on the recording lights. Stupid technology. Anyway, first super chat is from Harley. When an honest man discovers he's mistaken, he will either cease to be mistaken or cease to be honest. Which are you, Brandon? Dishonest or honest?
I'm honest.
Keith Milner. Brandon needs to show his workings out to say why the flight is impossible. Otherwise, his argument is just from incredulity. The problem is now, because we haven't been addressing the super chats as we've gone along, some of these relate way back to the beginning of the debate. So, do you want to answer that, Brandon? Or?
Yeah, I've actually detailed that in great detail. Why I think that flight is highly suspect and points towards a flat stationary Earth. On my channel, there is the Brandon Toy channel is an impossible flight. You'll see a yellow plane on it a little while ago. You check that out if you want to see the details.
Truth Nerd says somebody pushed a Foucault's pendulum with a stick. Therefore, science is a fraud and the Earth is flat. I think that refers to something you said earlier on, Brandon.
I think that's kind of a extreme argument from what I said, but okay.
The Snark says Brandon mentioned BMS. He's in the chat. You don't need to answer that. That was a statement. I don't know why I paused. Apologies, Brandon. Keith Milner again. You don't understand is the go-to argument because it's true. Brandon didn't bring any equations or explanations that supported his claims.
You don't understand is not an argument. And I did.
Doesn't stop it being
true or not. It's not an argument.
The next one is from Beard the Devil 1864. Brandon is just parroting other flat earthers' beliefs. He doesn't actually understand what he's regurgitating, hence why he cannot answer the questions.
Hence why I don't talk to Bearded Devil, because that is the frame of mind that he comes from, and it is pointless to have a conversation with him.
Okay, well, the next two questions are from him as well, I'm afraid, and he super chatted them, so you'll have to hear them. Brandon, how far away, in feet, inches, or miles from the observer is the finite vanishing point? I think you kind of, when you were explaining, you and Catz were explaining that to me, I think you covered that, so we'll move on to the next one, unless you want to say anything, Brandon.
No, it's dependent upon the height of the object above you.
Okay, exactly how high above the Earth is Polaris?
I don't know. I mean, not millions, trillions, or billions of miles, probably thousands, but I don't know.
Jess Looney says, Brandon, will you delete your channel if Catz debunks you? Because he offered to do the same.
And who would be the judge of Catz debunking me? Do we have a neutral arbiter? But the answer is no. We're not going to.
We'll get Baldy Catz. Baldy Catz.
Get Baldy Catz in. He's completely impartial. The trigonometry Catz presented explains both perspective and vanishing point.
That's the point of contention, that it doesn't.
Okay. Harley asks again, Brandon, it's sometimes okay to admit that you don't know or that you were mistaken about something because it becomes a great learning opportunity. It's a problem only if you stay willingly ignorant.
I agree. I live by those words as well. Good reminder.
Well, can I ask on that?
Yeah.
Sorry, on that. If you do genuinely think that, will you please go away and have a look at how trigonometry works? Have a look at the model you presented me for Polaris. have a look what I was saying, and then maybe we come back again and do a debate just on that when you have learnt trigonometry? Like, would you do that?
You know what? The trigonometry required for your model of how Polaris works is, I wouldn't even call it trigonometry. It's just triangles. It's simple triangles. You keep saying I don't understand. There is not much to understand. A, B, C.
The maths around triangles, though, isn't it?
Yeah, but it's so simple. I don't know what is it you don't think I understand, Catz?
Well, okay. I know it is so simple, but when I asked you to calculate the side of a triangle, you couldn't. When somebody put in the SOHCAHTOA into the questions before, which is trigonometry, you didn't know it. When I asked you about sine, opposite, hypotenuse, you didn't know it. I think you don't know anything about trigonometry. I'll be honest. I'm sorry.
Okay. Anamorphic Mind says Brandon is a Poe and he is still butthurt from getting destroyed on Gems Discord. Moving on. Have Brandon have Brandon draw what he's claiming from the actual viewpoint of the observer using perspective and a finite vanishing point. We addressed that a little bit earlier on, but thanks, be the devil. Brenda says, Brandon, could you please produce a drawing, sketch, or map of any kind that shows the relation of the continents on a flat Earth? And I'm hoping she doesn't mean right now this second, because we are literally 5 minutes from the end of the show, but I don't know if it's something you would ever consider addressing.
I could do that, Brenda. Not for you, but I could.
Why not for Brenda?
Oh, she's a huge pain in the ass. She's a huge pain in the ass.
Right. I don't know who she is, but JL Warren, good evening, sir. Good afternoon. It's not good evening yet. I'm confused. It's daytime. Please explain how the mathematics of wave propagation definitively prove a spherical model if the Earth is flat. Are you saying all maths is wrong?
No, not saying all maths is wrong. That's such a weird question to ask.
Okay. And the explanation of how wave propagation definitively proves a spherical model, do you want to address that, or?
I don't know anything about that subject, to be honest with you.
Okay, cool. John Watson says, Brandon, why do you think a solar filter gives you an inaccurate angular size for the sun?
When did I ever say that?
Yeah, I was going to say I may not look as if I'm listening, but I am, and I didn't hear you say that either. So we'll move on to the next one. Have Catz ask Brandon if finite vanishing point, the actual physical horizon of the flat Earth, is just a term used for drawing perspective. Well, I've asked him. Be the devil.
It's used for the finite vanishing point is used for drawing perspective because that's what matches the real world.
Next one is from X Penguin. This isn't a question. This will require an apology for me. All his lights just went out. Sorry, X Penguin. And Sean Hawkins asks, have Brandon show his EQ mount.
How's your EQ mount going, Sean? You still trying to get that thing working or what? Are you willing to take $200 for it yet? I think I can get that puppy working.
So you don't want to show it then, no?
I don't have my EQ mount sitting right here. No, this is a long-standing thing with Sean. It's
yeah. Oh, it's like an in joke, which is why I didn't get it. Sorry, guys.
Yeah.
Well, it's 5 minutes till show end. Thank you to everybody who super chatted. We've just had another one in from Spart344. Can Catz please address fully how we know the distance to various celestial objects and how we are not to suppose it's a few thousand miles away?
And how we're not to, well, I can tell you exactly how we're not to suppose. I mean, when we're talking about the, you could go into in-depth astronomy and you can look at data that's collected and, spectra that's analyzed, etc. for that, which isn't certainly my field. But if you just look at basic trigonometry, that will tell you that if these things are very, very close, then they do not match. If they were very close, we should be expecting way different observations from Earth than we get, which is what a lot of the show has been about. We can't just assume that they're a few thousand miles away and assume that explains what we actually see, because as we've talked about today, it just doesn't. But that's a really good question. Like, what are the astrophysicists doing to make those measurements? I mean, if we look at something like a Cepheid variable star, for example, like that's quite interesting. You can look at a Cepheid variable star, it will pulse over a certain amount of time, and then the time period it pulses over. We can link that to something called the period luminosity law, which will tell us its absolute brightness, how bright that star should be. Then we can measure its apparent, that's its absolute magnitude. We can measure its apparent magnitude on Earth. And then there's an equation that allows us to extrapolate the data. So, there are certain standard candles that help. But, you need to be asking an astrophysicist that question, I think.
And Global Mum, a super chatted, Brandon, where does the sun's light go at night?
Well, as we know, with mediums where it is more evident and we can see it firsthand, the sun is not so powerful that its light can be seen forever or through all mediums indefinitely, such as the ocean. You can only see sunlight approximately 600 to 1,000 meters below the surface of the ocean. So it is possible, and I'm not going to pretend that I know the exact reason why we don't see the light, that it just can't reach you. The sun's light cannot reach you that far. So when it's at that distance, you don't see the sun.
Sean Hawkins, super chat again. Thank you, Sean. So Brandon chooses to remain a liar. So I'm guessing this is something to do with whatever is going on between you and Sean. But thank you, Sean.
If you want to see something with regarding Sean, there is a video on my Brandon Toy channel called Sean Hawkins Leaves the Flat Earth, and you'll know exactly who this guy is. It is pretty freaking funny. One of my favorite videos I've ever done.
I know Sean. I know who Sean is. JL Warren. So I cite evidence, the mathematics of wave propagation, which is irrefutable because it's math. And that proves the spherical model, and you claim total ignorance instead of studying it.
Well, how could I study it during the 5 minutes or the 2 seconds when you ask the question, JL? If you want to send me some information, feel free to send me some information. You can come into my Discord channel, the Ranty Flat Earth Discord channel, and come and talk to me about the information. If you've got something that proves the sphere, I'm all ears.
And this is definitely the last question because it is now 5 o'clock our time. Is the underside of the top corner... Oh, shit, hang on, let me start again. Is the underside of the top of the container as tall as half the diameter of the flat Earth? If so, then how high is it at its apex?
How the hell would I know, bearded devil? You think I've been out there exploring the top of whatever container you're saying that there is on the Earth? I have no freaking clue, man. I'm just a guy sitting on Earth trying to figure stuff out.
And that, as they say, is that.
I got one more question, if you wouldn't mind, Creaky. Sorry, it just came in.
Yeah, go on, fire away. Yeah, no, go on, fire away.
All right, thanks, man. This is, again, from The Plain Truth. Ask Catz if he watched my debunk of slide 22, or does he simply hand wave dismissal and false accusations?
I had a hilarious time watching that. If it's the one where basically he claimed that I'd manipulated the photograph, which I've got, I'll put slide 22 on here so people can see what we're talking about. So yeah, let's do that, and then we'll call it a day. This is slide 22 from our debate, where I asked The Plain Truth where the ether band is. Where is this magic mirage? And we've got this boat taken 2 shots. One from 2 foot above sea level, one from 6 foot above sea level. I mean, these numbers basically mean nothing to me. What point I was making was there's no mirage hiding the bottom of the boats on here. And he did some sort of, he said it was CGI, basically, Creaky. That was his argument, CGI.
No way. How dare he use my catchphrase?
Yeah, the whole video, like, oh, Catz is using manipulated images and whatnot. But again, that's what you get when you've got no answer and you think a magical band called the ether band exists that makes us see things.
It must have been from the 60s because I've never heard of them. And we've got one last super chat, and this is the last one. How can you trust anything you say if you haven't looked into it beforehand? You have to refute the body of work and not just a few points, Brandon.
So before I disagree with anything in modern science, I have to refute the entire body of science that's been built up over the last 500 years and not just 1 or 2 things. Does that seem reasonable to you?
My argument would be
so.
my argument would be the reverse of that. My argument would be that people started off because the only observation they had was they'd walk out and they'd see the sun and the moon go around them, and they'd think they were on a flat Earth, and those observations they thought told them the Earth was flat, and that's where people started. It's when other observations came in that they then realized that the Earth couldn't possibly be flat. So it's not a case that the globe was there first and the globe has had time to put maths in place. The flat Earth was there first, but the flat Earth was wrong, and nobody's ever been able to put any kind of descriptions into place for it. That's why it died, and the only people who really believe in it now are people that can't comprehend and understand what the scientific explanations are for things. That's my explanation.
You had to get one more you don't understand in there. Appreciate that, Catz.
Sure. No. And I wasn't personally, but it is true. And that's what I went back to the very beginning, my opening presentation is, we just have to hand wave, dismiss, and ignore things like predicting the weather, seismology, all astronomical observation. We just got to ignore all of them. We've got to ignore the conspiracy side of it before we can start to even then try and convince ourselves the Earth is flat. And I do think that is relevant to the debate. It's not me being nasty. Surely you can see why I think that's relevant to the debate. It's not a personal insult. But do you see why I think that's relevant?
I know why you guys say it, because you just cannot comprehend how someone could have the same information and understanding of that information that you have and still disagree with you. That's what I think.
Okay.
And on that note, I think I'm gonna call time on this. Brandon, you are more than welcome back anytime you like. I'm sure Catz will agree with me, because you have done exactly what we expect all our guests to do, and you've kept it civil, and I hope you've enjoyed it as much as we have and as much as the audience have.
I have. Thanks for having me. Appreciate it. Good stuff, Catz. Let's shake hands.
Well, we said it would be competitive. We said we'd be respectful, but very competitive. It has been respectful. I have been as competitive as I said I would be, but that's what a debate is, and at the end of it, it's all over. So, don't walk away with any sour feelings, please, because we've been respectful, and that's the important thing. We've not been screaming over each other, shouting at each other. We've had equal time to speak. We've not been, calling each other names. We've just had a proper, heated, competitive debate, in my opinion.
Yeah, I would agree. Good stuff. Thanks, Creaky.
Awesome.
Thanks for hosting me. Sorry about the issue with my StreamYard. I didn't realize that didn't happen.
Yeah, no, it's fine, mate. It's fine. If you come back, we can sort that out for next time, just to make it a little bit smoother. So thanks to everybody who super chatted. Thank you for watching, and we're out here. Take care, everyone. We'll see you next Wednesday. Bye.
See ya.
See you. Okay, well, I'm not hanging up yet. I'm going to open up my Discord and see if anybody's in there and they want to talk about the debate or anything else. And I'm going to shout out the people who did send me super chats. Thank them, just to show my gratitude here. So I do appreciate that. And let's see if anybody is in the Discord. I was pretty focused on that. No one's in there, but if anybody wants to pop in, I will open that up. Let me read the super chats, and maybe I'll read some of chat before I go here. We did get a super chat from Taking Back Eden FE. Thank you very much, Taking Back Eden. And that was Brandon Toy teaching the teacher. Well, I don't know. I don't know trigonometry. I mean, how many times did he say that? That was getting very old. He didn't really argue against my points there then. It was just, you don't understand trigonometry, and then trying to pin their model on me. It's like he did not understand that I was presenting their model of how Polaris would work on a flat plane and debunking it and asking him to falsify how my model would work at long distance. I don't think he understood it. So I'm looking forward to his video that is totally, I am sure, going to skew the argument and just irritate the hell out of me.
Merry Christmas, Brandon and Ranty.
Hey, Gordzilla 37, $5. Merry Christmas, Brandon Ranty. Merry Christmas, Gordzilla. Appreciate that, man. Helvetica Bold sent £5. Thank you, Helvetica Bold. And upgraded membership to Fish. Thank you. Appreciate that. Appreciate all the support the channel gets. I really do. Helps me justify the time that I spend on it, which I love doing anyway, but it's a nice little added bonus. Take the wife out to eat or something. And not a big deal if anybody can't support it or whatever. I just appreciate it, whatever you guys do. And I hope you appreciate the work that I'm doing. Travis, thank you very much for the two $10 PayPal. So thanks, dude. I really appreciate that. Too late to ask him another question, but I see ask Catz if he'd like to put money on his lie that I called the images CGI. He did pretty much hand wave that away, didn't he? Saying that you said it was CGI. Oh shit. Josh the Flat Earth Jedi. It drops in the sky due to perspective and atmospheric effects. A perfect example is clouds appearing to meet the horizon. Polaris is higher than a cloud, so it descends at a smaller rate. Exactly. Was it just me, or did he not seem to understand that? Oh, show me the math. Show me the math. Show me the math. Like, they want you to take a math quiz. I hate that tactic, and it's effective with their audience too. That's the thing. They don't want to discuss concepts. They don't want to address your points. They want you to do a math test. I see some people in Discord. I'm going to join them now. And oh, I just moved Brian. Hey, what's up, guys? I got to unmute myself. Hey, what's up, guys?
Hey,
Hello.
Hey,
What's going on? Fantastic job.
King of debate, man. You did so well, man.
Really?
did so
You guys
well.
think so? I mean,
Oh, yeah.
You
wasn't sure.
ran circles around him, and all he could do is fumble out little like attempts at insults, and you don't understand. And show me more numbers, please.
I know, wasn't that something? And that was like the last half of the debate was just him going, "You don't understand trigonometry. You don't understand. Flat earthers don't understand." I mean, I was appalled, and even after I called it out, he still did it twice more.
You killed him, bro. You killed him. Show me the math. Show me the math.
Oh my
Yeah,
God.
describe me, Mr.
When
Catz.
you're presenting to him
Hold on,
the
hold on,
observations.
Bob, I have a question for Mr. Catz. I want him to show me the mathematical formula for how chocolate ice cream tastes. Go.
Yeah. Oh, dude, that other guy that was in there, that whatever Moss or whatever, that guy, he's like an idiot or ignorant or both or something. That guy was clearly biased and being really stupid about butting in and trying to ask you dumb questions or whatever.
I
He's
know.
like, why did you bring it up if it wasn't for calculating Corey? I was like, you idiot. He just explained exactly why he brought it up and why it has nothing to do with actually determining Coriolis. That's why he brought it up.
I couldn't.
All right, hold on. I got
was
the quote.
dumbfounded that they didn't understand why I was bringing that up. It was just like, what do you mean? And then Rumpus's comments. That's not for determining.
Oh,
no shit.
That should have been foul right there. Someone should have called foul over and over until they got the Rumpus thing to just end.
I've got the
That was
quote of the
bullcrap.
day. Are you ready? The quote of the day. Here it is. You ready? I didn't have anything for breakfast, but I had cats for lunch.
Oh, you heard that?
I have a better one, and I'm going to make a meme out of it. Triangle equals sphere Earth.
I like that. I saw you type that.
CC 2020. I'm going to make a meme out of that. Wow.
Hey, y'all see how quick he was on the draw with Rumpus's comments, dude. So he's debating conspiracy cats, Rumpus, and probably a couple other people, dude. They give their hand up when they respond so quick.
He was so far in the corner. He was so far back in the
He's
corner.
not
He had
bad
nothing
math.
else, so he had to get something from Rumpus or someone.
I've got a good one. It looks, they say to us, it looks flat, so it must be flat, right? And this is what they tried to say. Oh, it looks flat, so it must be flat. So how about it looks flat, so it must be globe?
Yeah.
Good one.
Oh shit. Yeah,
Bro, you did amazing.
you
exposed them for having nothing, absolutely nothing, just telling you don't understand. A triangle equals a globe. This was brilliant.
Oh, thanks. I'm glad you guys enjoyed it. Hey, give me a minute. I gotta take a restroom break. You guys keep the conversation going for a minute. I'll be right back. I can still hear you.
Yeah, dude,
Whenever they try to get him on doing the math.
The whole time, like, you need a list of formulas to debate them. You need to have your sheet of formulas in front of you, and they don't want to talk about reality. They want to talk about math, and that's where they lack comprehension. People with math skills like that, there's a fine line, but they don't invent shit. They don't build shit. They don't do nothing, man. They have comprehension of math and nothing much beyond that.
They think science builds bridges. They don't understand that science doesn't build bridges. Engineering builds bridges.
First of all, even if you can use trigonometry, all right, how are you going to determine the distance to the sun? How are you going to determine the angle to the sun? How? How are you going to determine the size of the sun? I mean, that's sheer fantasy.
Right, when he asked the question, well, how would you calculate the height here to Polaris? And I've never been in a real debate, so maybe I would have not been able to, think of answers or whatever. But here in my room, I very quickly thought of the answer. I wouldn't try to calculate to Polaris. That's your thing. So you can ask me all day long, how would I calculate the height to Polaris? I wouldn't try to. That's retarded.
Exactly. There's no possible way that they know the distance to Polaris, what Polaris is, nothing. All they know is how it moves across the sky. And
That's
people
right.
have known that for thousands of years. That's it.
And I don't know how they didn't understand finite either. Because what they're listen, there's a finite amount of, let's say, gold wherever we are. Right, there's a finite amount of gold in the UK. Right, that's a claim, and it's probably measurable. But when you're trying to talk about distances and things like that, it is that it's finite is variable. Because on some days you can see further than you should be able to on a globe, right? And some days you can't see as far as you should be able to on a globe. So it is absolutely finite. And if you are, say, 6 feet tall and you're watching a boat, let's say you can see a boat up to, the furthest I've ever seen one is about 27 miles away from around about 12 feet in elevation. So it was a long way away. But once you go, let's say, to 40 miles, you're never going to see that boat for many, many reasons, nothing to do with Earth curve. But everything beyond that too. 50 miles, everything at 50 miles away, everything at 60 miles away, 70 and 80, it's all going to fall in that 0.001 degree of optical vision. So everything from 40 miles up to 5,000 miles away is still going to be in that finite 0.01 of a degree. Simple as that.
No, it disappears because of math, Ranty. You don't understand.
Yeah.
Did you guys believe that list of shit he started off with?
Even if he just said Sakatoa, I wouldn't entertain that shit either, man. Even if he
There
just
wasn't enough triangles in
Sakatoa.
your explanation, Ranty. You must be wrong.
Oh man, listen, when I was looking at some of those triangles, I'm looking at the triangle, I'm thinking place yourself on the top of a triangle. So you're looking down and you can see a certain distance, right? So it ends in the triangle. And let's say he's put you at 100 meters high and you can see for 30 miles away, right, from 100 meters. So that's the distance. It's a triangle. You can measure it, yeah? But what happens if you wanted to then just say, well, what's 40 miles, 50 miles, 60 miles, 70 miles? It would be a flat line. It literally would be a flat line, and they don't understand that concept. Because it all falls into an angle. They don't understand. They kind of want to talk about angles, but they don't understand how it works optically.
Exactly. That's what I was trying to get at with the finite vanishing point, right? And and he ignored that point. He ignored all my points about Polaris, essentially, with just kind of this attack on, you forgot what you learned in school and triangles and to do some trigonometry on the spot, that kind of shit. But what did you guys think about his list of shit he started off the debate with during his monologue?
Oh, I wasn't there right at the beginning. What did he do?
Oh,
It's
8 minutes.
wiki crap. That's what it
through,
was.
just listed a
He
bunch
showed
of
some
straw
boats. He
men.
showed some boats, and I laughed because the one boat that he shows, which is obstructed by water, right? There is an obstruction of water in the way, but you can clearly see that it's a wave that's breaking. So you can see the flat water leading up to a point, and then you can actually see the hump of the wave where it's breaking. Now, I've got probably 10,000 videos which I could bring out any one of them right now and show you a wave getting ready to break on the shoreline and how it starts to hump up ever so slightly before it starts to break. And that's exactly what he's filming. And the only reason he's getting that exact image is because somebody went down to about a foot, let's say, and saw a boat in the distance and took an image whilst the wave was breaking in front of the camera. And that's the same image that whenever I see that, I have to laugh because you can see the breaking of the wave right there. Everybody that should take note of that image. Take note of that image. It's there. You can't miss it.
Oh, that's interesting. I'll have to look back at that. I'm going to watch the debate again and see what I did wrong and what I did right. I wasn't feeling during it that it was going fantastic, but he wasn't making any points. So I'm like, is this going good, or is he just like psychologically fucking me over here? That's what I was thinking. I'm like, if
you weren't in the debate, you might have been able to like get out some more clear like pointing out exactly what his bullcrap was. But I mean, obviously, when you're in it, you're probably nervous and trying to get all your thoughts together. But like whenever he was asking you to please explain the calculation that you brought up about the Coriolis and the military shells and stuff like that, like I think one of the best responses would be, it doesn't matter what the calculation actually is. It could be 17 elephants plus 3 elephants. The point is they put the calculation in, see where the shell lands, and then change the numbers until it matches. You can do that with anything. You could use any system you wanted with any symbols you wanted. It doesn't have to include any numbers at all. You're just using symbols to represent where the shell did land. You're not doing any math whatsoever to calculate where it will land.
Exactly. That's what I was trying to get across to them. And he says,
Right.
you don't understand based on what? What are you basing this on that I don't understand, that I don't agree with
Based
you?
on your clear explanation of exactly how it works. Clearly.
I mean, I don't know how else I could have explained that equation, solved it in front of him, but he would have said, you don't understand that equation, no matter if I had pulled up my own PhD thesis on the equation. And
I think if you would have had a page ready and read it directly from the book, exactly how they described the equation, he probably still wouldn't have recognized it's from the book and would have told you that you don't understand it.
I did. I read directly from the book how they used that calculation. That was straight out of the book, and he still was saying that I didn't understand it. But we had a super chat from Square Law. Globe beliefs are complex programmed worldview. That's a good description. I like that. Yeah, I agree with that.
Right, I've just put that image in. I just managed to grab it. It's a tiny little screen that I was able to get it on, so it isn't the best of shots, but it's the best I could do on the fly. But trust me, this image where I've circled it put a square box around it, that is where the wave is breaking. You can actually see it. It's much clearer on his original image because this was a little bit fuzzy. I had to take it off a screenshot that was only about a quarter of the size of the screen, so bear with me. But that is where it's breaking, and it's so obvious. I could see it. I've seen it every single time. I'm sure Travis would see this and go instantly, yep.
Yeah.
Breaking wave, man. He's filming a breaking wave. It's ridiculous.
I would have attributed that to proximate looming, but
that does have some properties of proximate looming because you look at the compression of the wave patterns. And then this right here is that fuzziness we see with proximal looming sometimes, where it's the atmosphere. And look at the top, the jaggedness. Yeah, this looks like a false horizon. It has all the hallmarks to me. It kind of looks like it goes straight up like that. You know, this is ridiculous. It might be a wave. Yeah, I think you're right, Randy. That's crazy.
It is. It's a breaking wave. Okay. It's a breaking wave. 100%. I've filmed so many of these.
I'm not disagreeing that there, are multiple variables, right? Because let's just take a different shot of a tanker, right? We've got other shots of tankers being cut in half as well. So you're not going to have a one-to-one example in each one like they are all the same. So there's so many different variables going on that we can't let them, dictate the conversation. But
I would agree with that, Travis. There's only one explanation in their model, but what we're finding is that there are tens and dozens of explanations that we can bring up, and just picking out one of them isn't going to be the same case for every single observation. You have to look at all the details in it. And this was just one that was very easy to debunk. As soon as I saw that, I was kind of laughing on my screen and thinking, I hope you're going to see that there. But definitely, that's just a wave.
I was trying to keep it away from optics because I just didn't want to go there. And he did mention optics in the beginning too. I had written that down. I thought it was pretty easy, but pretty funny what he says, that we make up all these other explanations for not seeing the bottom of stuff. And I was thinking in my head, I know 3 or 4 things that are based on real world observations that we see again and again that actually do block the bottom of things at a distance. The atmosphere does do that. So if anything, they're denying science in that case.
Yeah, I mean, the thing that I struggle with Catz, and the last time I was in a debate with him and Gleam, I lost my shit because he makes these blanket statements that there's not enough time to say, okay, justify your claim. You just said this, okay? Because he'll just say, like he did in answering your questions, that I said that it was CGI. Okay, nowhere in my explanation, nowhere did I accuse him of manipulating the photo. Nowhere, and nowhere did I accuse or say that it was CGI. Right. So rather than have a debate, whenever he makes a claim, I personally would never let him move away from that. Say, okay, listen, we're not going anywhere. Justify what you just said right now. Because he can't do it. He just hits you with machine guns of boom, 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 and there's just not enough time to deal.
Kind of related to that, I think it would have been good to hold his feet to the fire when he suggested switching over to Polaris. That if you would have just been like, okay, yeah, if you want to concede on Coriolis, we can move on to the next topic. Because I mean, that's all he had left. He was back so far, he needed to move on because he had nothing. And I think it would have been good to just bring that out and be like, if you want to concede on Coriolis, sure, we can move on to the next thing.
Yeah, I was trying to type that into the chat, that exact same analysis, and I just didn't get around to doing it. But yeah, that's exactly,
I mean, that's basically what he did without admitting it. He conceded without admitting it. He had nothing.
Yeah. If you looked at the pattern, each of his arguments ended after me showing, my diagrams, my argument, giving my argument. Each of his arguments ended, you don't understand. You've shown me nothing. I don't understand your position. It was like, that's all his argument turned into both times. You don't understand math.
Oh, and also, you've looked into this and I haven't looked into it very much. I'll get to it after, that kind of bullcrap.
Right. I'm going to make a video. So I can't wait to see what kind of hit job video he comes up with. I have a feeling it's going to be pretty funny.
Can I share my screen with you guys?
Yeah.
Yeah. Okay. Let us know when I'm presenting.
I can see
second.
it.
Okay.
I got the
Just trying to keep
dancing squares right
now. Right. No worries. Let's see how this works. Can you see it yet?
No, let me. Oh, there it is. Got it.
Get the seagulls and whatnot.
Yeah, so here we are. So in the distance is some buildings, Barrowing Furnace buildings. I mean, this is such a long way. It's like 18.4 miles, I believe, to those buildings. You shouldn't see any of them on the globe. But what I've done here is I've dug myself into a trench and I'm filming across the water. Now the water's almost flat. It's barely any movement on it, and I say it's almost flat because it's never ever just 100% flat. But we do have a tiny bit of swell and a tiny bit of chop. And what you're going to see is that at some point in a minute, there's a wave that's going to come up, and there we go. How's that? The entire buildings, the birds, the seagulls, they've all gone. Now, that's just a little wave breaking on the shoreline, right? And look how much is it. Now you see the bird, now you don't. Now you see the bird, now you don't. And I'm going to show you.
Back and forth over the globe, over the horizon.
I'm going to show you now how high the waves were at this time, hopefully. There we go. Look how little these waves are. They're maybe an inch or so high, if that. Just little trickles at the shoreline. Nothing much. Very little breakable waves. And go back to the start again. So now you can see the buildings in the background. It's pretty unclear, but people know if they've followed my work. And there's the birds. And yeah, then the birds are hidden. Everything's gone. It's as simple as that. A little wave hiding things. It's a bit more exaggerated than the one Conspiracy Catz said and showed, but it's just the same effect. It's literally the same. You can obscure anything with a wave if you're beneath it. Simple as that.
Well, and you certainly shouldn't see those buildings at all from that viewer height.
Nope.
I'll tell you that.
No. They are long gone to Earth curve if you believe in the globe model, and a lot of this research that I did was all around this area, so you shouldn't even see them at, 16 miles, something like that. So this is 18.4, and you're seeing probably 3/4 of those buildings. So that was a little hole that I'd dug in. there it was, actually. There was the hole that I'd just dug, and you'll see the wave. There you go. It comes in and it fills that hole in that little trench. That was where I had my camera. So that's how low I was. But yeah, it's just an optical effect. What Conspiracy Catz did with that one image. These little waves, these tiny little trickly waves, will hide anything if you're lower than the wave.
Makes sense to me.
Yeah, any intelligent, logical person that listened to that debate could clearly detect you talked circles around him, you destroyed him. Don't let anyone convince you otherwise. That guy was wrecked repeatedly.
Oh, cool. I'm glad you guys took that away from that. I thought I did pretty good too. I was nervous in the beginning. But I did calm down about halfway through and tried to keep my composure. He pissed me off a little bit in the middle there. I don't know if I was unmuted. You guys could probably hear me, but I don't know if I was unmuted.
I probably would have started flinging insults because that guy was acting like such a moron. Like he was. I wonder if he has got something mentally wrong in his head that he can't properly formulate thoughts and ideas.
Jesus,
Yeah, so
Bob.
we have we have Syrif, SYRPH in the chat, who actually says, hang on, Umya, you have a wave right in front of your camera. What did you expect? If this is your excuse for the sailboat picture, then you failed miserably unless that boat had sunk already. Right, okay, so I am not saying that that's a wave at the shoreline, but you don't understand shoaling. Now, I'm assuming that you've just come to this channel probably from watching the debate over on Agree to Disagree, and you've come over here and you thought you could come over here and try and discuss optics with people like Travis and myself and people that have explored this. And what you're probably seeing here is the shoaling effect, the breaker, probably around about 50 meters to 100 meters away. And you're getting a little bit of a breaker there. Places in Hawaii, Australia, all that kind of stuff where they got little shelves, and you're just watching a little breaker about 50 meters away from the camera. Not breaking right at the shoreline in my example where I just showed what a wave can do, but a bit further out. So maybe when you start looking into fluid dynamics, you should jump on the panel and come and debate us about this, because I'll debate anybody all day long on optics. You want to come and talk about this sailboat? Get your ass on here right now. Let's have it out. Hop on. Don't be just a chat troll.
Yeah, and
That
let me
was a
link
challenge if I
the
ever heard
channel
one.
invite here so that invitation is open. Although I don't have much time, but this probably won't take that much time. Let me.
Would you call that throwing the glove down?
There you go.
Indeed, I've said it. I don't think anybody would debate me on optics.
No chance.
I went on Fight the Flat Earth, and I took on Fight the Flat Earth and his sidekick. Oh man, they didn't know anything about it. It was embarrassing. I totally humiliated them for 2 hours because they just wanted to talk optics, which was great.
Yeah, right.
And even though I go,
right?
Yeah. Oh, it was so good.
Surf also says, "Don't pat him on the back. Brandon did horrible. He never even made a point." Well, why don't you come in and tell me about how I didn't make any points? You and Randy can talk, and me and you can talk as well, and we can all straighten this out. There's the link for you. Or are you just here to troll? And Sean Hawkins, you're a freaking joke, dude. I'm glad you spent your money and gave it to Creaky to ask really stupid questions especially about the EQ mount. I'm so happy to have you back in Flat Earth so that I can make another video when you inevitably quit the Flat Earth out of embarrassment again.
Who's the guy that does the filming in Hawaii? What's his name?
B-Ball.
B-Ball, yeah. I'm going to just... There's a video out there, actually, that shows this shoaling effect off the shoreline about 150, 200 meters away, and it's perfect for this. Let me find it.
Oh, Sean Hawkins. I predicted that Brandon would come here and straight here and brag about winning. I nailed it. I've been here the whole time, you jackass. I was broadcasting the debate on this channel as well. You're not so bright, Sean. I nailed it, he says. Oh, shit. Anyway.
Well, I mean, he's right. You did nail it. I mean, this was a pretty clear, easy victory. He would not actually argue any points. He would just mumble through his insults and say, "You don't understand." At least you brought something. At least you actually tried to explain something. All he did was sit back and say, "I don't understand your point. Explain to me the thing that you brought, and you don't understand all this other stuff." I mean, he didn't make any actual points himself. Maybe this guy's projecting because his guy didn't actually make any points.
Exactly. Well, or accuse me of not understanding my own argument, which I found to be pretty amusing. But anyway, so yeah, I'm just packing the family up. I don't have too much time. We're getting ready to go to the mother-in-law's for Christmas stuff. I imagine you guys are also doing all that family stuff.
We got our Christmas tree yesterday.
Just yesterday. Holy crap.
Yeah, well, it's the first time we've ever actually bought a real Christmas tree. We had a fake one in our apartment, but now we're in our house, and so this year we went and got like a real one. and we just went and picked it out last night or whatever. So.
Oh, did you just get a house this last year, Bob?
Yeah, we moved in like early October. We got moved over to our house. We'd been living in a 3-bedroom apartment for a good long time, and before that a 2-bedroom apartment. But we have 5 kids, so that was scrunched. Yeah, so now we're in a house, and it's much nicer. I have lots of room to pace.
Congratulations. Yeah, we did that last year too, and I was like, oh my gosh, I can get away from my family now. It's nice. I have my own office. But everyone's got their own space.
I'm presenting another video. This is B-Ball's boat behind the waves. And this is hilarious. Tell me when I'm presenting and you guys.
Come on, B-Ball.
Is
See it.
Is this a that's a hell of a choppy horizon, that, I tell you. I mean,
oh my goodness. Does that boat have jets on it or something? Is it a rocket boat?
And they would say that, oh yeah, it's behind Earth curve, that. So what they're saying is these ginormous waves that are breaking between us and the boat.
Come on, B-Ball. You're better than this, man.
Classic. That they're going to try and claim that.
Brandon just told a lie. B-Ball is not better than this. This is B-Ball.
I was thinking about asking, is he? Is he better
he's
than
not.
this?
He's definitely not.
What's up, Rukia?
Yeah, not too much, just working. But yeah, B-Ball stuff is a joke. I mean, he takes the most distorted area or disturbed area to film in. It's even worse than Lake Pontchartrain, right?
Yeah,
it's amazing. And then he doesn't even know what shoaling is. If he lives in Hawaii and doesn't know what shoaling is, he's got a real issue.
Oh, in Hawaii, absolutely. I mean,
yeah, it's the shoaling capital of the world. Anyway.
I've tried to educate him. He doesn't want to know. But anyway, all I'm showing here is basically there is a boat hidden by water, right? No problem. And I'm sure if you took a screenshot right now, like that, you could take this screenshot and claim that it's Earth curve, right? You could do that. The fact is, though, it's a wave. Everyone knows it's a wave. When you see the whole video, when you see what's going on, you can tell that it's a wave that's obstructing the boat. It's a very choppy day. The boat bounces up and it bounces down, and you've got the waves breaking in the foreground. Very simple, and it's just an optical effect. But I'm sure any glober could take a screenshot of from at any point during this video, like just there, and say, "Oh, well, actually, most of the boats in there, but right now it's hidden. Now it's hidden behind Earth curve, right? Now it's hidden by more Earth curve. Now you can see it."
Well, and if you look at it, you can just tell this is not, it's not condensing. There's no horizon that is created by the waves getting closer and closer and closer and closer until you're on the top of a ball and then it slants down. I mean, just look at that. You would literally have to ride up those waves, and then you're telling me there's a hill on the other side? That looks like a fucking hill of water, dude. That isn't even what the Earth curve would look like.
And why is if it's really the Earth, it's behind Earth curve, why is it bouncing in and out of Earth curve? Did you see how he actually just stopped it there on that high part of the wave? If I go back just a fraction, right, to here, just where he stops it. So hang on, just about right. So we're seeing there's the back end of the boat, but you're going to see a big wave break in a sec there, and he pauses it right. Look where he paused it. He paused it right on the breaker of the wave where it covers most of the boat. Dude doesn't understand how things get smaller with distance. Quite clearly, 132 feet, 25 feet. Yeah, but that's further away, mate. That's further away.
Show me the topography of the bottom of that bay or ocean or whatever he's in right there. Show me the topography right there. I guarantee those waves are being pushed up.
Oh, they are. They are.
Because the bulges look like they're coming up, and then the wind is just cresting the white caps. Because the waves, you know what I'm saying, it's just a mass of water being pushed up. It's not necessarily a huge wave or swell. It's just a mass of water being shoaled up, and then the top portions are being pushed over by the wind.
Mm-hmm.
So easy to see in a video.
this is their own work. So this is a guy, B-Ball for Life. He's a globe earther who's put this video out as proof of globe Earth. This is his proof of globe Earth. Except that, you know, you could take this to probably any university, people that study this kind, you know, oceanographers and things like this, and they will just simply tell you, yeah, it's just the waves, mate. That's all it is. You don't have to give them any distances. You don't have to show them this stuff that's giving some kind of, oh, right, this is proof and measurements for a globe. Just show them this video and just say, what do you think's happening here? They'll take a look at it and they'll say, looks like it's a bit turbulent, a bit choppy. It looks like there's a bit of shoaling going on. Yeah, why? What am I supposed to see here? And then you'll turn around and say, well, somebody's claiming that this is Earth curvature. So then they're going to be like, well, we're not going to claim that, because you just have to look at it to know that you're just not looking at Earth curvature right now. Simple as that.
Yeah, it doesn't take any in-depth analysis to see that this is not the hump of the Earth that you're looking at. I mean, give me a break, man. B-Ball always does this, though. And you know what's so funny? B-Ball thinks we're all so stupid, and he thinks we're in a brainwashed and all this shit. He's so confident of himself, and his arguments are just the worst, man.
Oh, yeah, they are. And how do you argue with people like that? I mean, like I say, Conspiracy Catz has an image where there's part of the boat missing, right? No context to it, right? So the image that I've presented to you, and I've taken a screenshot of it, there is a boat hidden by water, right? But there's no context to the image, right? Now, I've just showed you a video with the same effect, with a boat hidden by water. We're all in the same consensus that it's not Earth curvature, right? So when he's presenting an image like this and saying this is Earth curvature, no, you can actually, it's better on his image because you can actually see the hump of the wave that it's breaking. You can actually see it better. But it's very clear that it's just a shoaling effect. And they will just put their hands up and say Earth curve. And a lot of the globers, 90% of the globers, will just clap their hands and agree because they don't come onto a Flat Earthers channel and hear how they would explain this particular image.
How many observations do we need to show them? Or how many real world demonstrations do we have to do, like our fish tank stuff, or Pete the Great or Pebble in the Pond's videos in his garage that clearly show the atmosphere blocking things from the bottom up? How many times do we have to show them these other phenomena until they will actually acknowledge that these things take place? They never will.
Blinded by science.
Yep.
Blinded by science. That's it.
I think once they start to have to be pushed into a corner to agree on these things, then they're going to have to admit that there are other things that are obstructing. Now, Conspiracy Catz did put some fog images up. So he put some images of fog saying that you can't see as clear on this particular day. So he may have heard me talking about that in the past. I don't know. But it's a very simple thing that the horizon will appear closer to you if it's a foggy day. On other days when it's much clearer, you can see a lot further. But he's sort of taken the first step to saying, yeah, okay, so fog can stop you seeing further, right? That's one thing. But that's just the very, very minimal thing that he could probably get away with. Try talking about, like you've just said, the guy that lifts the garage doors up and down, or the inferior mirage, or the ether. And I know that Travis calls it the ether band. It's probably a bit confusing because there's other things we talk about with the inferior mirage, but it's the same sort of thing. Whether we come to a consensus to say it's all the ether band or what have you, but it is an area that causes this inferior mirage, causes distortion, but they don't like to talk about that.
Nope, they don't like to talk about that. Much easier just to look at something and say, oh, yep, that's Earth curve, and just move on with your business. But
yeah, it's obstructed. We can't see it. We can't see the bottom of it. Must be Earth curve. But this is the arguments we were having 3 years ago. Seriously, we were having these arguments 3 years ago, and it seems like we're being dragged back down this path of let's see a wave obstructing a boat and claim that it's Earth curvature. You know, I mean, it's that retarded. That's the level that they're coming back to. Show us a wave that's obstructed by that's obstructing the bottom of a boat. I mean, come on.
I sometimes think they're just trying to waste our time and get us to focus on what they want us to focus on, Randy. That's why I ignore some of the stuff that they say and some of their arguments that they bring up and just laugh at them, because we're on to, you know, bigger and better things, trying to figure out what's actually going on in this Earth. And we can certainly address those conversations when they come up and remind people of what's happening and show them all the great work that's been done. Optics, Travis continues to do great work. Pebble in the Pond continues to do great work. A lot of people do. Flats, a ton of people do. You were doing it before you stepped aside, but we have to set our own agenda. We have to set our own agenda and do what we want to try to figure things out.
The guys doing the miniature boat stuff is fantastic.
Oh, absolutely. Great stuff. Yeah.
I mean, just go and see, they've got a little pond, the way above any kind of curvature. It's only like 400 feet long, but the effects they're getting are the same effects that we see with the inferior mirage and things hidden from the bottom up. It's exactly the same. And the distant shoreline that's distorted with an inferior mirage is exactly what you see when you look at sometimes distant buildings with the same inferior mirage on it. Just great stuff shown in the miniature world. But do the globers go out and repeat those kind of observations and then try to explain it on a globe model? Did they do that?
Yeah, that's why we got to get past these knuckleheads. I mean, it's not going to, it's not going to change. Can I hijack this for real quick for a second? Because I just went out again while Brandon was debating and took some shots. So I have some shots from yesterday and today, and I didn't think about this event until just now looking at it because I was confused. So let me bring up a couple of panels if that's okay. Is that okay?
Sure. Yeah, let me make one more point before we move on. Maybe I forgot the point as soon as I said. Oh, I wanted to tell you guys that I heard Blue Marble Science the other day say that what was happening in Pebble and the Pond's images where the light completely disappears is that the white garage door in the background was tricking the sensor into not being able to see the light. And I thought that was really funny. But I'm going to step away from my computer and let you...
Yeah, he told me that.
Yeah, that's right. You were in that conversation in Gems.
I was talking to him, and that's what he said is the center of the camera.
That was hilarious. But I'm going to step away. I got to start getting my family ready. Go ahead and present, Travis. I just won't respond to anything, so you guys keep it going. I'll have to end this in a few minutes, but you guys can keep going for about 10 minutes.
Okay, so can you guys see my screen?
Let me get switched over here. Okay,
Ranty, are you still here?
Yeah.
Okay. So when I go out and shoot, I normally take a shot of what I can see with my naked eye, and then I zoom about halfway, take a shot, and then I go full optical zoom. Okay. So the middle frame and the left frame were from yesterday, and the reason why there's a different tone is because the sun was passing over. Okay. But the two on the left, the left one and the middle one are 357 optical zoom. Right. So if I looked up the data right now, it would tell you is 357 millimeter. Okay. But what I don't have yesterday is typically what I have always thought was the full optical zoom, which was 428. Okay. So that was really strange to me because I was looking for a full optical zoom. I was looking at the data, and none of my pictures say 428. Now, this picture here on the right is this morning. This is 428. I don't have a 357. And you know what I've always thought now that I'm talking this through? I have a lot of shots that are 357, and I've always thought, how did I stop at that? How did I stop at 357? Because it doesn't tell you on your screen what the focal length is. And I think I've just figured out something right now that I've talked about but never put together with this. And that is this. On the right here today, because I know, I just got done doing it, this is full optical zoom. Boom. And it's 428 millimeter. Yesterday, here in the middle, this was full optical zoom, but it was only 357.
I'm not sure what you're saying.
I know it's pretty abstract to think about. Okay, so
is there any cropping that's gone on with this?
If there is, I just tightened up the top and the bottom, but
All right,
I don't think so. I could go back and make the panel again, but I don't think so. I can show you this one right here. This one I did crop a bit, but again, it was only to fit in. Just real quick. I'm sorry, just real quick. It was only to fit in the frame. So this left one is the initial photo, and it was fully imaged, right? This one here in the middle is the same focal length, and it fit exactly next to this one. This one here on the right is 428, and it was larger. So what I did was simply simply shrunk the frame to get it all, so it's not wonky.
So we're talking about a bit of magnification, you think, is going on?
Yes, right. So here on the left is 357, but you'll notice that I frame these shots here with the tower always in the top right corner. Okay.
Left corner.
I'm sorry, top left corner, right? So here's 357, and when it gets here, I stop, click, boom. And then this one was framed this way too, but this is 428. Okay, so now if I had, but again, what I'm trying to say is that the only time I know that I'm shooting 428 is when, or at least I thought, let me say this that way. In the past, I've always thought that the full optical zoom was 428. But it depends on what the medium is doing to the observation as to how much I can fit into the frame. So that on one day I can fit more into the frame, but I still stop here with the tower at the left. But I've got more here. But this is full optical zoom, and it's 357. I don't stop at 350. I don't. The only
so
time
are you saying that you thought that they were the same focal length, but they're actually different?
Right. So look. So like I say, I went out on this day and shot. Click, 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 boom, boom, boom. A couple days later, I go back and look, and I don't have any 428s, but I have this, and it's 357. And that, like I said, that always puzzled me in the back in before, because I'm like, how do I happen to stop at 357? Because, like I said, there's no way to know. Like, I can't stop at a quarter way on my digital display and try to get it as close as I can to 357 or 2/3 or 4/5 or whatever. There's no way to stop in that scale and hit 357. The only way I can hit 357 is if it's full optical zoom.
That is interesting. I have to walk out my door now. Randy, I don't know if you want to keep this going. If it's possible for you to end the stream in the account, if you want to keep it going. Otherwise, I'm going to have to.
I think I can. Yeah, I can end it if you want.
Yeah, okay.
Think.
It's up to
Let
you.
me just double check that.
Thought I'd
Let me just double check.
Okay.
Let me just double check that before you run out.
Cool.
But anyway, just putting that out right now, it's now something else that I've got to think through and be more intentional in terms of.
So does that mean we need to throw these out then? Because now before the claim was that they were all the same focal length, they were all the same zoom and stuff.
No. So okay, so look, you don't throw these out because the left image here and the right image here are the same focal length. Okay.
Okay.
So you can clearly see that the level of the water is the same. I didn't do anything here to match up the water. I opened this file, spread the paint out, inserted this file, clicked and put it just right in the frame, and it just happened to line up with the same horizon. Okay. But you can clearly see that the house here is squashed and the angles are not as crisp.
Right.
Even though that this is a hazy image because of the conditions, right? So if and you can even see right here, even too, the tree line is higher than this tree line. If I went in,
so what do we do with the third image though?
Well, okay, but see, that's I don't know. It was just right now for contrast for me to put.
So can I just interrupt one just a sec? Brandon? Yeah, I probably could, but without being able to share the screens, I won't have the same sort of controls as you would. Maybe you should end and then record an after show.
Yeah, if you guys want to do that, go ahead. I'll end this one and
just start recording.
Same channel, you'll just start a new one, right?
I'm just dropping this bomb in right now. I've got to eat lunch and then finish doing what I wanted to do before I have to go to work. But Bob, just to go back to your question. So
I gotta walk out.
I don't know.
I'm gonna end this right now.
Okay.
Thanks everybody.
Thanks, Brandon. Thanks.
Cheers, everyone.
Bye guys.
Take
Merry
care.
Christmas.